thank you so much for enrolling in this course. It's an honor to be your instructor, and I can't wait to start teaching you Swift. And I have so much to share. I want to tell you how programming changed my life. I want to tell you how you can get the most out of this course. And most importantly, I want to help you write your very first line of Swift code. Now, before we get into that, we have to make sure that we have Swift on our computer so we can go ahead and start using it. Now, sometimes this requires a really big download. So I want to make sure that everything's rocking and rolling, and then we can dive into some of this other stuff so that in case we need to download it, we can get that started while we're talking through some other things. So if you're on a Mac, I'm going to show you how to get Swift installed on your computer in this video. But if you have a Linux or a Windows machine, I have separate lectures for those. So go jump to the section called Installing Swift on a Windows or a Linux machine, and I will show you how to do that. So once you're done there, come back to this lecture and we'll move forward. But assuming that you're on a Mac, let's get started. So we need to get a program installed on our computers called Xcode. Xcode is a free program from Apple. It allows developers to make iPhone, iPad apps, Apple Watch apps, Apple TV apps, all that good stuff. And for us, most importantly, it'll allow us to write Swift code. Okay, so in order to get this going, we need to download it from a special place because the newest version of Swift is Swift 3. That's what this course is about. You're learning the latest and the greatest, but it's in beta mode right now. So we need to go to a browser and go download this from the Apple developer website. So open up any browser you want, Chrome, Safari, Firefox. I'm going to open up Safari. And so once you have your browser open, we need to go to developer. Got to spell that right. Developer.apple.com. Okay. Developer.apple.com. Go ahead and hit enter on that. You'll get to this awesome screen that kind of shows some cool stuff. What we want to do is scroll down here and click on Xcode. Okay. So click on Xcode. It's telling us, oh, look, beta now available. So go ahead and hit this download button. All right, now it's going to ask you for an Apple developer account. Now, if you don't have one of these, which you probably don't, what you need to do is go ahead and create an Apple ID. And if you already have an Apple ID that you use to like download apps or whatever, you can work through that one and it will get you all set up. But you need to make sure it's ready to be a developer. Now, you don't have to pay any money for this. You just have to register it as a developer account. But once you do that, go ahead and put in your information and click sign in. So once you're all signed in, you should get to this downloads page, which shows you all the beta things that you can get as a developer. What we want is this Xcode 8 beta. So just go ahead and click on the download button. And you're going to want to get this started because it's a 5.5 gigabyte file. I have no idea what your internet connection speed is, but it's probably going to take a bit. So while that's downloading, we're going to go ahead and talk a little bit. Like I said, I'm going to share my story, how to get the most out of this course. And then once it's done downloading, we're going to write our very first line of Swift code. So while this is downloading, let's go ahead and chat for a second. So now that we got Xcode downloading, I'd like to share a little bit of my background and my story. And the reason for that is you and I are about to embark on a pretty legit journey here. I'm going to be teaching you Swift, and you're going to hopefully be learning these things for the very first time. It's going to be a complete game changer for you. So there's a lot of stuff that we've got to go through here. I have so much to teach you. I think the more that you know about me, the better this experience is going to be. I don't want to be just some little dude in the bottom right corner of your screen teaching you stuff. I want us to have a connection. And the number one thing that I want you to get from this lecture is that I care about your teaching. I care that you actually learn this stuff and that it makes an impact in your life. And I think as you hear my story, you'll understand why I'm so passionate with that. So how did I start programming? Well, the story starts back in 2008. I left for 2 years to Japan for a church mission. And during those 2 years, I wasn't really connected with the things going on around the world, especially in tech news. I was just kind of oblivious to that. So I come back in 2010, and as a welcome home gift, my dad got me a brand new iPhone 4. It had come out like maybe 3 days earlier, and the idea of apps blew my mind. It was crazy. I couldn't believe all these different apps. Like before I left, yeah, there was like an iPhone, but it just kind of had the pre-installed things on it, like, you know, the maps and the camera, whatever. But now there was these third-party apps, and there was an app for everything. Like I remember the first time playing Angry Birds. That was amazing. I remember playing Scrabble with my aunt, and she pulled out a Scrabble dictionary app when she wanted to look up a word. I was like, what? That's a thing? Scrabble has their own app? Like, this is insane. I also remember the first time I mistakenly took my phone into the bathroom with me. It was like 45 minutes later after I was just mesmerized by this little thing. My legs had fallen asleep, so I couldn't walk straight. Like, oh, just apps completely changed my life. I was like, these things are cool. I want to be a part of them. And I decided I wanted to make an app. The app that I wanted to make was a mini golf scorecard. I thought, if you're playing mini golf, you got your ball, you got your club, and then if you have to have, your scorecard and a pencil, that's just too many things to hold. If we can make the scorecard and the pencil just one thing, your phone, well, it's going to be that much easier to keep track of your score, blah, blah, blah. So I wanted to make this mini golf scorecard app, and I thought, how am I going to learn how to do this? Well, I did whatever else I had done in my life when I wanted to learn something. I hit up Google. So I just Googled how to make an iPhone app, and I found YouTube videos, tutorials, online courses, and I'd start each one. I'm like, yes, I'm going to make the mini golf scorecard. But with each one, it never worked out. I don't know if you've experienced this, but some people who are really, really smart and are great at what they do, they can't explain it to people. I just felt like this dumb idiot that people would talk, and I'm like, I don't even know what you're saying. You're trying to teach me this code stuff, but it sounds like you're speaking another language. They'd be like, all right, now in this function, we need to add a Boolean in the return value. And I'm like, whoa, whoa, whoa. You can't just say these big words and don't explain what they mean. Like, I just don't get it. And so it was really frustrating for me. I don't know if you felt that before, but I just watched thing after thing, and I just felt like the dumb kid that couldn't get anywhere. So after doing this forever, I figured I got to find someone in person to teach me. So I went to like programming meetups, and I just hound all the different iOS programmers with questions. I took a programming class at the college that I was going to. I just tried to get any sort of like programming information into me in hopes that I could eventually make an app. And finally, it took like 2 years. I had my very first app on the App Store. It was an app that taught you how to do weightlifting. It would kind of organize YouTube videos to say, hey, if you want to work your biceps, this is the top video for that, or triceps, it's this sort of thing, whatever. Wasn't a very useful app, but to me, it was the coolest thing in the world because it was mine. Yes, I kind of gave up on that mini golf scorecard dream, but since then I've actually gone down and back and made my mini golf scorecard, which is cool. But ever since I had that first weightlifting app in the App Store, my life was apps ever since. I started making apps for work. I did contract work, full-time, part-time, internships. I was also doing apps for fun. I made like a money converter app. I did an app that would schedule text later and stuff. Just like anything that I thought would be cool, I'd start making it. Like apps were my entire world. Like I said, I did it for money and I did it for fun. Like the only thing I think I did outside of apps was probably play basketball. But so I just was completely in love with apps. And then back in 2014, Apple announced this new programming language. It was a huge shock to everybody, and the new programming language was called Swift. Now before, in order to make apps, you had to use this programming language called Objective-C, which is a pretty tough language. I didn't really know because I was starting from scratch, so I wouldn't know otherwise. But I had lots of people who were programmer friends say like, yeah, Objective-C, like it's a little bit strange. And so this new programming language called Swift comes out, and I hear from Apple, one of the big things that they tried to make into the language was that it would be easy for beginners to pick up. And it kind of put me back in that mode in 2010 when I wanted to make an app and I just couldn't get anywhere. And I just thought, Apple's come out with this new programming language and it's supposed to be easy for beginners. I hope people are teaching that in the right way, in a way that people who are actually beginners can understand. And so I just thought, you know what? Maybe I should teach. So I made a little course on how to teach Swift and it exploded. People loved it. I had so many people come up to me and say, not come up to me, they message me online, but they just say, yeah, I've tried so many things, but no one actually knows how to talk to me as an actual beginner. Like you walked me through stuff. And so I just want you to know with this course that I really have your best intentions at heart. I know what it feels like to be a complete beginner and just think, I can't do this programming thing, I'm too dumb, or like this is just too complex. No, you can do it. And I promise I'm going to walk you through everything. Now, I'm not saying this is going to be a walk in the park. You definitely have to put in effort, and it's going to take some brain work. You're not going to get it on the first time every try, but I'm going to be there for you. And so with this course, I just want to share some things about how you can get the most out of it and make sure that it's one of the best courses you've ever taken. So in the next lecture, I will cover that. In this lecture, I want to share how you can get the most out of this course. And it's really only 2 pieces of advice, and they're very simple, but if you follow them, they will have a profound impact on how much you get out of this course. So number 1 is I want you to ask questions. Simple, right? But I can't tell you how many students get confused on something and they are afraid to ask a question. Now, Udemy has this awesome question answer system where you can go post any question and I and other students will see it and we will answer your question. I am very active inside of the question forums. I will make sure you get an answer to your question. You can also see other questions that students have asked and see the answer to those, so you can instantly get help if you share the same problem with someone. But please don't be afraid to ask. Don't think, oh, this is a dumb question or something like that. Like, do you remember who you're talking to? The ultimate dummy. It took me 2 years to make my very first app. Like, I will not judge anybody for a stupid question. So no matter how ridiculous it sounds, please just ask it. I and other students will be there to help you. So the next piece of advice that I have for you is to be adventurous. And what I mean by that is the basic structure of this class is I'm going to show you some new programming concept, okay? I'm going to teach you, kind of walk you through it, and then I'm going to have you put, rubber to the road, actually try and do it on your own. And I hopefully by doing that, you will start to pick things up. But it's inside of these that you really need to be vigilant. Don't just go ahead, skip to the next lecture and see how to answer that question. I want you to actually work on it. Do it yourself. This is where the real learning takes place. And if you're doing it, you don't exactly remember how to do something, go back and watch the previous lecture. Maybe ask a question inside of the class. Do whatever it is you got to do, but put some effort in to actually doing your own thing. And by being adventurous, I want you to do those, but then also move beyond that. If you just think, oh, I learned this really cool thing, maybe I could use it to do X, Y, and Z. Go out and do that, take a pause from my course and go work on something cool because, you kind of have a spark. You're like, oh, this is awesome, right? The main thing here is I don't want you to be a robot that just does exactly everything that I do. I want you to kind of explore on your own and really cement this stuff inside of your brain. So those are the 2 pieces of information I have for you. I would now like to share what is honestly a video that has changed my life. So I told you programming changed my life. This is another kind of game changer thing for me. So this is a clip of Steve Jobs. He's kind of explained his view on the world. I'm going to let it roll and then I'm going to talk about it.
When you grow up, you tend to get told that the world is the way it is and your life is just to live your life inside the world, try not to bash into the walls too much, try to have a nice family life, have fun, save a little money. That's a very limited life. Life can be much broader once you discover one simple fact, and that is everything around you that you call life was made up by people that were no smarter than you. And you can change it, you can influence it, you can build your own things that other people can use. Once you learn that, you'll never be the same again.
Wow, what a powerful video. And I want to reshare one of the lines that Steve said. Everything around you, what you call life, was made up by people who are no smarter than you. Do you realize that you can do this programming thing? You may be thinking, programming, it's for those whiz kids. It's the kids that go on to like Stanford University, do all this crazy stuff. Like maybe they've, child prodigy, been programming since they were age 5. No. You can do this. Think about who said this quote. Steve Jobs, the guy that made Apple computers, the first Macintosh, iPod, iPad, iPhone, Apple TV. He was behind this company, right? And there was a lot of people involved, but he's telling you, guess what? You and I, we're on about the same level. I'm not that much smarter than you. Okay? He's telling you, you can have an impact on the world. Once you decide, I'm going to create things. I'm going to make things that other people can use. And I can't think of a better place to do that than with digital things and programming. Think about if you make an app, you can put it up on the App Store and instantly that app is available to millions of people across the world. They can go download your app from the App Store instantly. You can make something that people use every day on their phones. You can change people's lives. And that's why, for me, programming has changed my life because I love making things that other people can use. For me right now, when I'm making this class, I get excited that I can make something that will help you learn programming because I know people struggle with it because I struggled with it as well. Well, hopefully I pumped you up with enough motivation. You're ready to rock and roll with Swift here. We're actually going to write our very first line of Swift in the next lecture. I'd just like to take a moment to say I've really put a lot of effort into this course, and when you get prompted by Udemy to rate this course, I really hope I've earned your 5-star review. Those reviews really mean a lot to me as an instructor. They're telling me how I'm doing, and the better reviews I get, the more courses I can make. So if you've really enjoyed this course, I'd ask for your 5-star review. If you don't think it's up to snuff, please let me know, and I'd like to make any changes that I can. And with that, let's go ahead and move over to the next lecture. Let's start coding. So hopefully Xcode 8 is all done downloading. You should have a file like this, xcode 8 beta.xip. If it's not done downloading, go ahead and hit pause on this video, wait till it's done so we can move forward and write our very first line of Swift. But assuming you have this, just go ahead and double click on this. This is going to get everything ready to start installing it. Now, remember, this is a 5.5 gigabyte file, so it's going to do this huge process where it starts verifying this file that you downloaded, and then it's going to install it, all this good stuff, but it's going to take a while. So I'm going to go ahead and cancel mine just because I already have Xcode 8 beta installed, but for you, just remember this could take some time. Please be patient. So once it all is done downloading, you should have Xcode beta installed in your applications. And it's important to note you might have the regular version of Xcode already installed on your computer. For this course, you want to make sure that you use Xcode beta because this is what we're going to be using to learn Swift 3. It's the very latest version of Swift. That's why we have to use the beta. So if you want to open up the Xcode beta, this is the way that I do it. I hit Command spacebar at the same time. This gives us this cool little spotlight search that we can open up any program. If you just start typing Xcode like this, you should see that I have the regular version of Xcode. I also have Xcode beta. So make sure you select Xcode beta and double click that thing, and you should get a welcome screen like this. And again, if it's the very first time you open it, might not be as snappy as mine, but once you're there, you should have this. It should be welcome to Xcode version 8 dot something. Yours may not be 0.0, but probably will be. Once you're there, we just want to go ahead and write our very first line of Swift. Make sure that everything's working on our computer. So what we're going to do is click on this thing that says get started with a playground. Don't worry, I'm going to walk you through playgrounds, what they are, everything in the next section. But let's just use the defaults for this. My playground iOS, that sounds fine. We'll hit next. Then it's going to ask us, where would you like to save this? I'm going to put it on my desktop. Okay, just hit create. You can see we have this little file here now. And, oh, Xcode quit on me. I'll just go ahead and reopen that. So once you have that, you should have some text inside of here that's saying, playground, blah, blah. It doesn't matter what it is. We're going to delete all this. And then I want you to type the following. Do a double quote and type hello space world. Okay, and then another double quote after that. That is your very first line of Swift. That means everything's working, okay? So if you don't know about this hello world thing, often in programming, if you're trying something out for the first time, a new programming language, a new platform, whatever it is, people will make a hello world program where they just want to have hello world show up somewhere. And that kind of means like, oh, this is my first step into this thing. So there you have it. You've written your first line of Swift code. We are now ready to rock and roll. Let's move to the next section where we're going to start learning. Woohoo! And welcome to your first section where you'll actually do some Swift programming. With these programming sections, I always like to have an intro explaining what you're going to learn over the next couple of lectures, and then an outro sort of to wrap everything up. So for this very first intro, I'll say we are learning about variables and constants here. Why are these important? Because these are the building blocks of Swift. I kind of relate it to math, like the very first thing you got to learn in math is how to count. Like if you don't know how to count, you can't do addition, you can't do subtraction, you can't do multiplication, division, all those crazy things, algebra, geometry. You need to learn how to count and learn what numbers are first. So these are like the very fundamental things that you need, variables and constants. Let's go ahead and jump into it. So in the last section, we wrote our very first line of Swift code, and we wrote it in something called a playground. You may be wondering, well, what the heck is a playground? Let me share that answer with you. When you open up Xcode for the first time, right, it will show you a couple options you have. And if you want to do this one that says get started with a playground, I think there's a great definition of what a playground is right below it. Explore new ideas quickly and easily. Essentially, a playground is a place for you to write some Swift code and instantly see what happens with it. You can kind of really easily take a look inside on what's happening. Whereas if you try and, do some stuff with Swift inside of an app or something, it's kind of hard to see the results. So for example, if we hit create a new Xcode project, this is the way to make iPhone, iPad apps, Apple TV apps. You can see all the different options here: watch, TV, OS X, which is, Mac stuff, right? So with these, it's like you can make an app, but then anytime you want to test your code, you have to hit run, then a simulator will pop up. Like, it's pretty complicated. Whereas with this playground, right, look at this one that we have on the desktop. I just double click this thing and boom, I can instantly start typing some code and see what happens with it. Now the basic flow of a playground is you type your code inside of this white area and then the results of that code show up on the right. So I'm just going to type some code. You don't have to follow this. I just want you to see how this works. I'm going to say like var name equals Nick, and let's just do one more line so you can see some stuff. Okay, so as you type things here on the left, you will see the results of that code out here on the right side. So we can go ahead and, let's just keep these things. I'm going to show you a couple of preference things that you can change. But so that's the basic idea of a playground, is that you can type some code and instantly see what happens with that code over here on the right side. It's a really good place to learn. So now the next thing I want to talk about is if you want to customize your experience with the playground. Of course, you can resize it any size that you would like. If we go and click on Xcode and then hit preferences, we can go to font and colors here. I have mine on something called presentation. There's an even bigger one called presentation large, which I think is a little bit too big for me. I've got to be able to fit the code in there, so I'll do presentation. But there's all sorts of different color schematics here. Midnight's a really good one, low key, dusk, default, Civic, and you can take any one of these and then customize it even further than you'd like. The one that I used to always use was dusk. This was kind of a good one to code late at night. But so if you ever want to go change what your Xcode looks like, you can go to Xcode preferences. It will pop up this. If you click on fonts and colors, you can go change this. So I'm going to go back to presentation and we'll X this out. And that's kind of the quick intro into playgrounds. And I should have noted this. If you want to change this little side thing here, you can make it really big, really small. But again, that's just kind of the results of the code. So, and the other thing I wanted to note is the name of the playgrounds really don't matter. So you can see that I named this one My Playground. If I click out of that and then click on this name, I can change this to like I am Nick, something like that. It's totally fine. All this is a single file that holds your code. You can open it up again and the things that you typed before will show up there. Okay, so there you have it, your little tour of playgrounds. Now we're going to be talking about variables in the next lecture. In this lecture, I'd like to talk about what variables are. And remember, like I said, variables and constants, these are the building blocks of Swift. So we want to make sure we really understand this. And I'm going to walk you through all of it. Now, a variable is something that holds a piece of information. I think a great way to think about this is if you've taken algebra before. Do you ever remember solving for x? Right? X was a variable. It held some piece of information like a number, and sometimes you had to figure that out. But a variable is just something that represents some other value. It's like holding a value. So let's go ahead and delete the code that we have inside of here, and let's actually create our first variable. So I'm going to come down here, and to create a variable, you just type the words var. It's kind of short for variable, var. So you say var, then you give your variable a name. So let's say, for instance, I want a variable that will represent my age. So I'm going to say var space and then give it the name of age, just lowercase like this. Then I'm going to hit space, and with a variable, you can put some piece of information inside of it. So I'm going to say var age is equal to, use that equal sign, and my age is 27. So I'm going to say var age equals 27. So what does this code mean? Well, it means I created a variable named age, and this age holds the value of 27. And you can see that age actually holds the value of 27 if I go below here on a different line of code and I type age. And if I type age again, just have it a couple times, you can see each time I type age here on the right, it'll show the value of 27. So what happens if I change age to something like 22? Well, now you can see all these update to 22. Maybe I change this to like 5. all these will change to 5. So really all a variable does is it holds some piece of information. So now so what did we type? We said I'm going to create a variable named age that's equal to 5. And now anywhere that I type age, it's essentially the same thing as the number 5. Okay, and you can do it with more than just numbers. We can do it with letters. If we're going to use letters, we have to put quotes around those letters. But so instead of creating a variable that holds age, let's create a variable that holds a name. So I'm going to say var name. This is kind of funny. The name of the variable is name, but var name is equal to, and I'll put my name in there. I'm going to type Nick. Okay. So now that we've done this, we still have our old age ones here, so let's go ahead and delete those. But you can see anytime I type name, I get Nick out on the right. And if I change this to Rick, look what happens. All the other ones change to Rick. So you're going to have your very first exercise here. All I'm going to ask you to do is to create your own variable, but you'll receive all the instructions for that on the next one. I just want you to be able to write this code completely by yourself and be able to get it to work. So do that, and then we'll move on to learn more about variables. So how did that little exercise go? I hope it went well. All I asked is that you make a variable named age and set it equal to whatever your age is. So you probably had something like this: var age is equal to, and then some number. For me, that's 27. Maybe we're in the same club, but it's probably some other number. But these exercises, I want you to get used to this flow of me explaining something to you, like I explained variables, and then you kind of going out and doing it on your own. It's by doing that I think you'll really learn things. So enough about the exercise and stuff. Let's teach something else, and that is that variables can change over time. So for example, when I say here var age is equal to 27, and if I type age and age on each of these lines of code whenever they're run, and that's a good thing to know about Swift and code, is that they run on a per line basis. So like this gets run and it says, okay, they created a variable named age is equal to 27. So kind of the output of that, or the result of that, is they're saying, okay, something was made and it was equal to 27. And if I type age, it says, oh yeah, that's equal to 27. If I type age again, oh yeah, that's equal to 27. So each of these lines of code is saying that, hey, age is equal to 27. And if I change this number to, like 22, 25, right? Like it updates at every other point here. But something that's interesting is with variables, we can actually change the value that variable holds. So here I've said var age is equal to 25. You can see both of these also are equal to 25. But if I go in between these two ages and I now say age is equal to, and I set it equal to a new number like 7, well, look what happens. Okay, come on, Xcode, update for me. There we go. So I said var age is equal to 25. So I created this variable named age is equal to 25. Boom, we see that output. If I type age again, it says, yeah, age is equal to 25. But now I'm saying age is equal to 7. Well, now it says it's 7 here, but then also on this next line, it's saying that it's also 7 here. So you can actually change the value of age over time. And it's not just age, it's any variable, right? So again, if I delete this, you see how this is 7 now. If I delete this, you can see it's just 25 all the way through. But if I go ahead and put that back, saying, okay, now age is equal to 27. So that's why I say a variable is a container for some value, and the value inside of that container can change. So if we go ahead and say, back to kind of the words things in text, if I say var name is equal to, let's have it be equal to like Sean. Okay, if I type name a couple times down here, we can see each time that we type it, it's going to be Sean. But if I kind of somewhere in the middle here say, you know what, I want name to be now equal to Carla, look what happens. Xcode, come on, boom, now it's Carla on the other side here. So variables can change with time. Now it's important to note that if I say here name is equal to Sean, which is like a word, and then all of a sudden I try to say, you know what, name should actually be a number, and I change this to like 15, the playground and Xcode is going to yell at me. It's going to say you can't do that. Once a variable is like a word or a number, it has to stay like that. through the rest of the program. But anyways, I'm going to dive more into that into the next lecture. It's kind of out of scope, but that's all you need to know about variables, that they hold a piece of information and that piece of information can change. So let's go ahead and do an exercise. Make sure you learned that. So I got you up to speed on variables. There's something that holds a piece of information, and the piece of information inside that variable can change over time, right? Like we changed age, we changed name, whatever. Now we're going to talk about constants, and constants are very, very similar to variables in the way they're set up and used. In fact, I'm going to show you an example here and you're going to be like, well, that looks like the same thing, but they do have a very key difference, but I'll show that after I've kind of explained the setup of constants. So to make a constant, we're going to use the words let to represent a constant, let like this. I really wish personally Swift it would have been something like const or something like that, but I guess those words were too long, and in kind of some other programming languages, let is a way to represent a constant, so I guess they just thought let's do this. But regardless, the way to make a constant is the first type, let, like that, and then we give our constant a name. So if we're going to go back to that age example, I'll say age, and then we can set that equal to something. So again, my age is 27, so I'm going to enter 27. So this looks just like a variable, but instead of var, we said let. And that's kind of the big difference here. Variables use var, constants use let. Like if I just change this to var, this is valid code. If I change it back to let, totally fine. And you'll see both a constant and a variable hold a piece of information. If I come down here and I type age a few more times, you can see 27, 27, 27. If I change this to 26, they all update to 26. It's the exact same. In fact, I'll change this to say var, right? And they update like that. Now, the difference between a constant and a variable is that constants, once they have a value inside of them, once they hold a piece of information, they will not change. It's kind of like once you put something into it, it's like cemented in there and it will not change ever. You can't change them. So with a variable, right, like I said, oh, this is 26. You know what? I actually want age now to be equal to 5, right? Like I do this and it shows, okay, it was 26. Now age is equal to 5. Well, guess what happens when we make this constant by changing this to let? Well, Xcode is going to yell at us because it's like, hey, you said this thing was a constant, age was a constant, and now you're trying to change it to some other value. So that's the big difference. With a variable, it holds a piece of information, and you can change what's inside of that variable at any point in time. But with a constant, once I say age is equal to 26, I cannot change age. Age can't be 0, it can't be 1, it can't be 2. No, it will forever be 26 as far as our programming is concerned, right? Like, and when you're creating a constant for the first time, I can change this to say 24, or I can change it to be like 21, but I just can't do this where I say after I already said age was going to be equal to 21, I can't change it to something else. Watch, even if I say age is equal to 21 and I try to set it equal to 21, I still get a problem because it's like, no, even though it's the exact same thing, you're trying to change it. You can't do that. So if we delete this code that tries to change it, you can see this is totally valid, right? The constant, if we type it a couple times, it just shows up 21, 21, and we can change this to some other number, but constants cannot change once they are set. So hopefully you got constants and variables. Of course, I've got a little exercise for you to make sure you've nailed it down, but those are the basics of variables and constants. So as I said earlier, I always like to end a section with an outro that sort of wraps everything up. And for this section, what did we learn about? Variables and constants. Both are similar in the way that they're a container for some piece of information. The big difference is a variable can change what that piece of information is, where a constant cannot. Okay, so those are sort of the big differences between the two. And I hope you understood that. I really try to keep lectures short and to the point, and always follow up with an exercise to make sure you're picking things up. Really hope you're liking this style, and if you have any questions, please post them. I'll be there to respond. But with that, let's keep moving and learning more Swift. This section is about strings and ints, and these are very important topics in Swift. I'd say almost as important as variables and constants. The cool thing about strings and ints is they're going to take the learning that we have about variables and constants, and they're going to build right on top of them. We're going to take what we learned and go one step further. So without further ado, let's dive into it. Let's start things off by learning about strings. So let's open up the playground that we have. If you have any code in there, go ahead and delete it. We want a nice, fresh, blank canvas here that we can run with. And so strings, what are strings? Strings are basically a way to represent text inside of our Swift programming. And we've actually already been working with strings, you just didn't realize it. So I'm going to go ahead and type in an example of a string, and I'm going to show you where the string is, and you'll kind of say, oh, okay, I sort of get that. So I'm going to use a previous example that we had. I'm going to say var name is equal to, and I'm going to set it equal to my name, Nick. So you're saying, okay, I know from the variable section, var name, I'm creating a variable named name, and I'm setting it equal to Nick. So what you don't know, but now you will, is that this double quotes here with the name Nick inside of it, this is a string. A string just means text inside of Swift. So anytime you want to represent some sort of text, you can just use double quotes and then put some sort of, words, letters, numbers, whatever it is that you want inside of there. And that's important to know. It's not like it has to be one word here. I can say Nick is a cool dude. Okay, this is a totally valid string. And the way that we kind of say this is that this is a string variable. If we wanted to make a string constant, we would change this to let. Okay, so now this is a let constant named name. Let's go ahead and do a different example here. I'm going to say var my friend is equal to, let's do a friend's name here, Landon, something like that, right? So again, strings are a way to represent text, and you can put whatever you want in here. Look what happens if I put some numbers. Well, that's totally fine. This is a valid string. This is considered text, not numbers. If I get rid of the double quotes on this, well, now it is considered a number. Do you see how the color actually changed from being red to blue here? But if I put those double quotes back, it goes back to being red. This is a string. You can also have empty strings, which just means if you do the two double quotes like this, it's saying, okay, this variable called my friend is a string. There's just no text inside of it. Okay, and like I said, it can be as short as this, and it can be long as who knows what. Just like keep typing forever and ever and ever. And you see, as I type, it goes on to a new line if things are too big. But you can't all of a sudden just put a return in here or a new line by hitting enter. Like that doesn't work. Your code has to be all on one line, and if it's too long that it won't fit inside of just one line here, it will kind of wrap to the next one. But this is considered one line here because I never hit enter, and if I hit enter again, I could start something else down here. I could change my friend to something else if I wanted to, just like maybe now my friend is Haley, something like that. But again, Xcode will handle all the flow of that stuff. So I've kind of gotten to some details here. Just remember, strings are a way to represent text, and you do that by putting quotes around stuff. Kind of a fun thing to do if you want to is you can actually uppercase or lowercase things. So for example, you see Nick is a cool dude. If I normally just type out name here, it will say Nick is a cool dude. But if I do after the name of the variable, which is a string, if I do dot and then start typing uppercase, you can see I get this auto search result. Let me click on this. So if I do name.uppercase, it takes all the letters inside the string and capitalizes them. Nick is a cool dude. I can also do the same thing here. If I do dot and start typing lowercase, it will get this lowercase right here. And you can see it uncapitalizes everything. So in this example, the only letter that I had capitalized was the N, and it undid that. But you see if I change this from to cool or whatever, it'll sort of bring that down. So I have an exercise for you to make sure you understand what strings are, and then we'll move on from here. So this is easily one of my favorite lectures in the entire course, and that's because we're talking about emoji. I love emoji. Like I said, I lived in Japan for 2 years, from 2008 to 2010, and it was during that time I really learned to love emoji. Like, I would be texting people, and people would respond back with emojis in their message. So for me, I really liked it because I was trying to learn Japanese. It was really hard for me to read. Like, it'd take forever to decipher people's text, but when I used emoji, I could really grasp what they were trying to say rather quickly by just saying, oh, it's a picture of a snowman. They must be talking about that it's snowing outside or something like that. Like, So for me, I really like that. But I've also found like sometimes you can just represent what you're trying to say best with emoji rather than words. I know that sounds crazy, but I honestly think emoji is a great way to represent yourself sometimes. So with that, I'm going to talk about why I think emoji is so important to Swift and why I think it makes it a really great language. So first off, the thing you need to know is that emoji is just like any other sort of text. Like, let's look at this string that we have here. Let name be equal to Nick, right? So here we have 4 characters inside of here, a capital N, an I, a C, and a K. That represents my name, right? Well, emojis are just like a letter or like a number, right? They're just some piece of like information that we can use inside of text. So on a Mac, to get to your emoji, I don't know about Linux or Windows, but just hit Control, Command, and Spacebar at the same time while you're typing, and you get this cool little box that you can get to any emoji that you want to use. So for example, I'm going to put a smiley in here. Well, let's do the upside down smiley. That's kind of cool. So here you can see I have Nick upside down smiley, and this is a totally valid string. I can like copy this as much as I want. It could be just emoji. Like, what I'm trying to convey is that an emoji is just like a letter inside of a word. It's just a character, right? So you might be thinking, yeah, that's kind of cool. Like, and it's cool that Swift supports that, because a big thing is not every programming language supports, putting emojis right in the middle of a string. Like, that's something that's fairly unique to Swift. There's others that do it, but it's really nice with Swift. So to take things a step further, you're like, well, why is that a cool thing? Well, there's lots of different languages in the world, right? English, German, Japanese, Chinese, French, Spanish, like whatever. And each of those languages will probably have some form of their own, like letters or symbols, whatever it is that they use to represent their language. So for example, if I want to add Japanese in here, I have a Japanese keyboard installed on my version of Mac here, but you can see if I want to type like some Japanese, I can type inside of this string like konnichiwa, okay, which means hello. So I can have this string that has English, emoji, and Japanese inside of it, and you may be wondering, well, why is this cool? Well, the reason that it's cool is that if you are a non-native English speaker, it means it's really easy to use your own kind of dialect or language inside of Swift. Like inside of your strings, you can just put it in here. There's not any special code you had to do. And I can't tell you how unique that is to programming. Like, that's a pretty big deal. But like I said, there's others that allow you to put, letters from different languages inside of here. And the big thing to note here is there's this thing called Unicode. It's basically the standard. I think it's an open source thing, but basically this Unicode group has made a way to represent every character in every language with some sort of number, and they include emoji in that, but that's the way that all this works. So Swift supports Unicode very, very well. But the really cool thing is that not only does it support it inside of strings, but it supports it in the naming of things like a constant or a variable. So watch this. If I want a way to represent my name instead of calling my variable name, I can call it an emoji. Like, let me find an emoji that I think represents me. Maybe I'll do this little detective guy with this skin tone or whatever, right? Like, this is completely valid code in Swift. Now, I can't tell you how unique this is. There's a lot of programming languages that will let you put Unicode stuff inside of a string, but in Swift, you can do it as the name of variables. And the reason I think that's a big deal is that if you're a programmer who speaks like Japanese natively, right? Like, you don't want to have to type out all the names of your variables and constants in a different language, right? Like, if you could do it in your own, that'd be so much better. So in Japanese, the word for name is namae. So I'm going to do namae like this. And now I can represent name in my own native language and use this throughout my code. Like, if I copy this and then paste this a few times, you can see the same thing shows up. And so because Swift supports emojis, but the bigger thing, because Swift supports Unicode, I really think it makes it a great language for anybody in any country, not just like English speaking people. So again, I'm going to go back to the emoji ways here because I just think this is so cool. Like, let's do the lady dancing. Okay, so we put her in there. We could copy paste down here, and it's totally valid. The name of this constant is this lady, right? I can change this back to a variable. I have to go back to my US keyboard here. I'm going to say, so I can type var there, and you can see this is completely valid code. This little dancing lady, this represents my variable, which holds this string. So, like I said, if you're an English speaker, maybe this isn't the coolest thing in the world, but it really shows how this is a great international language. And if you're someone who's not a native English speaker, maybe start naming variables in your own native tongue. That would be something that I think would make the code much more familiar to you and would kind of put your own personal touch on things. So with that, that's probably enough of emoji. I went kind of a deep dive into this, but you can tell how much I love emoji. I've got a quick exercise for you to make sure you got everything about emojis. All right, so let's go ahead and get rid of this emoji silliness. Now let's talk about something called ints. So very simply, ints are a way to represent a number inside of Swift. Remember, strings are a way to represent text. Well, ints are a way to represent numbers. And like you could probably guess, you've used ints before, you just didn't realize it. So if we go ahead and make that example variable called age, and we set that equal to 27, well, what is this number? This is an int. Okay, so anytime we say something's equal to a number and it shows up in this blue, that means that it's an int. Okay, there's nothing really magical to show about this, like, but I would like to refer to what I said earlier, right? Remember that once you create a variable and set it equal to like an int in this case, or a number, we cannot change it back to a string. So if I say, now I want age to be equal to Nick, this is not valid because we said this variable age is going to be an int variable because we set it equal to a number or an int. Now we can't set it equal to a string. Same goes for if I say, name is equal to Rick, and then I come down here and say name is now equal to 3. Xcode is going to yell at me because it's like, hey, you can't do that. Also, there's some cool things that you can do with ints, like some math. Notice here if I say age is equal to 27, and I want to know how old will I be, or what age will I be when I've lived the amount of time I've already lived one more time. Like, what if I double my age? You just do age times 2, and look what happens. Does the math for you. I could do times 10 if I lived 10 times, right? Like, there's all sorts of cool stuff that we're going to do, but we're going to be covering that math stuff in the next lecture. For now, just know ints are a way to represent numbers. In this lecture, we're going to learn about something that brings the world of strings and ints together into one. It's called string interpolation. So let's go ahead and just get 2 examples up here. We're going to have this var age equal to 27, and I'm going to make a new variable called name and set that equal to, for example, Rick. Okay, so let's say I want to make a string that tells me about my name and my age. So, I could type out here with just 2 quotes, Rick is 27 years old. And I could change this a little bit to say my name is Rick and I am 27 years old. So this is kind of a sentence about me. I'm going to extend this a little bit to the right so you can see everything. So this is a completely valid string. I could set this equal to a variable if I wanted to, like I could say var info about me is equal to this. This is also a good point to tell you when you're naming variables or constants, they should all be one word. There should be no spaces inside of them. If you're going to do multiple words, capitalize the first letter of each word. So info about me is info, capital A, capital M. But you don't capitalize the first letter. Never with naming a variable or constant do you have the first letter be capitalized. And I believe you can't start with numbers. Let me see if that's true. Yeah, you can't start it with a number. But anyways, so here, We don't have to do that. I just want to show you that we could if we wanted to. This is just a string that says my name is Rick and I'm 27 years old. So this is a nice sentence about me, but what happens when I decide or I grow older and now I'm 28? Well, then I have to go back through my program and change this to be like 28. And let's say I change my name from Rick back to Nick, then I have to go and change these things. What string interpolation does is it takes variables or constants and puts them directly into a string. It takes the value that's inside of them and puts them directly in here. So for example, let's delete Nick here. And instead, to do string interpolation, we want to do a backslash like this. And then we're going to do a parenthesis, okay? And then inside of there, we're going to do the name of whatever variable or constant it is that we want to add. So in this case, we want to add name. So I just type name into here, and look what happens. We get on the out here, my name is Nick, and I'm 28 years old. It took what was inside of the name variable and put it inside of the string. Do you see the connection there? And look what happens. Let's say I change Nick to something completely different, like Sean. All of a sudden, this says Sean now. Like this string will update to what's ever inside of this name variable. Isn't that cool? And we can do the same thing with age, right? So let's delete 28 because now we want it to reference whatever age is. So we do that backslash and then parentheses. Then we type the name of the variable that we want to put in there. So for example, age. Now look what happens. My name is Sean. I'm 28 years old. If I change this to 208 years old, it updates. I change this to Haley and this equal to 5. Like, boom, it updates. So string interpolation, a really big kind of nasty word, but all it means is adding variables and constants into a string directly so that way you don't have to like type out whatever the change is. You can just say, hey, whatever age is, whatever name is, I'm going to put that directly inside of this string. So there you have it, string interpolation. Congratulations, you made it to the last topic that we're going to cover here in this section, and it's about something called types. Now, types basically just describe different sorts of things that you can put inside of variables and constants in Swift. In fact, we've learned 2 of them already. We've learned about strings and we learned about ints. And we have a lot more to learn, but we're going to save that for another section. But I just want to show you how you can use these types and know the difference between things. So let's go ahead and delete just this bottom line of code. So now that we have this variable age that's equal to 5 and this variable name that's equal to Haley. So again, what are types? They represent what goes inside of a variable. Remember, a variable holds some sort of value. Well, the type is saying, all right, this value is a int or this value is a string, okay? A type, 2 examples of a type are a string or an int. So with these, this variable age equal to 5, this is a int variable and this one is a string variable. The name one is a string variable. Now, if you want to explicitly express these things for their specific types, you can do that, something called type annotation, but let me show you it here. And I think it will help you kind of understand types a little bit better. So when we say var age is equal to 5, we can do after the name of the variable space, colon, and then type the name of whatever type it is that we're looking for. Type the type. So in this case, it's an int, so we're just going to type capital INT. Just like that. And for this one, this variable name, which is a string, we're going to do space, colon, and say this is equal to a string. So you're asking, all right, what's going on here? So adding this colon with the int and the colon with the string, this does not change the code at all, but all it does is say this variable age, this is going to be an int. And the reason that this is kind of important is like, what happens if we tried to change this to some string? Like, hello, like we do this, well, we're getting an error because we're saying, hey, you said you're going to make a variable age that's going to be an int and you try to pass a string into there, right? Whereas if we didn't have this specification, Xcode will look at this and say, okay, they created a variable named age and it's equal to hello. Well, they must want age to be a string variable. So when you don't specify with this little colon thing, Xcode will just assume whatever it is that you passed into there, in this case a string, it's saying, oh, okay, the type of this variable should be a string. Essentially what, you don't see this code, but essentially what Xcode's doing in the background is it's saying, all right, this variable age, it's going to be a string. Whereas if you specify that this thing is going to be an int, well then it has to be an int. If we keep this as a string, we get an error, but as soon as we change this to something like 45, well, Everything's working. And you can do some cool stuff like this. For example, if I say, variable age is an int, I don't have to set something equal to that age variable yet, right? Like I can then on a different line say now age is equal to 40. And this only works if you specify the type there. You can't just say variable age like this and just say, well, eventually I'll give it some sort of type. No, if you're going to not set that variable equal to some value, you have to specify, okay, this thing is going to be an int. Now you may be wondering, well, what are the different types out there? And really, that's the next couple of sections in this class is we're going to be covering different sorts of types. But let me get back to this right here. I just want you to really remember types aren't really that confusing. All they are is saying, okay, remember we have variables and constants that hold some piece of information. And all that types are saying that, okay, if you put something into this variable, if I say this is an int variable, only ints go into there. So the type is really important to say, okay, you can only put these types of things inside of this variable or constant, okay? So there you have it. Of course, I have an exercise for you to make sure you're sort of picking up on this stuff, but congratulations, let's move to the outro. So in these last two lectures, we really learned some kind of basic building block stuff. And I'll be honest, this isn't the most exciting stuff in the world. I think it's cool that we're writing Swift code and you can get to know playgrounds a little bit better and how to write Swift, and you're setting an awesome foundation for yourself. But honestly, it's not that exciting. I'll tell you where things start to get exciting is in this next section where we start to do some math and work with numbers, and you can see, whoa, with programming, you can do some pretty cool things, and I promise it's just going to get better and better from there. So congratulations on making it this far, but let's keep trucking. There's a lot to learn. There's this misconception out there that if you're going to be a great programmer, you also have to be really good at math. Well, let me tell you, that is not the case. In fact, through programming, you don't have to be that great at math. You just tell the computer what you want it to do, and it will do all these calculations for you. So in this section, we're going to learn how to use math with Swift, and of course, we'll cover the basics, multiplication, division, addition, subtraction, right? All the basic stuff, which you need, but it won't be too hard to cover. But then we'll dive into some more advanced stuff about how to do like exponents and rounding things, stuff like that. So we also are going to learn two different types in this section. We're going to learn about floats and doubles. Remember types, I said strings a type, int's a type. We're going to learn about two more here, so you're going to keep building your knowledge of types. So with that, let's go ahead and dive into the math. So I was about to start this lecture, and then I looked at the name of our playground, iamnick.playground, and it's just kind of a bizarre name. So I'm actually going to click this and change it to math.swift, because that's what we're working on in this section. You can name yours whatever you want, but I just thought, I think I'm going to update this. So I'll double click, open this up. If you've got anything in yours, go ahead and delete it. We want a nice fresh canvas for us to start painting our Swift, if you want to consider this art. I don't know. But let's talk about math. So math and Swift is really, really great. They work awesome together. You can do really basic stuff, and just like you would put into a calculator, you can put it inside of Swift. So let me show you some basic stuff with like addition, subtraction, all that good stuff, right? So I'm going to do 10 plus 3. You can see I don't have to use any variables or anything. If I type this into this playground, you'll see on the right I get the answer 13. Okay, what happens if I do subtraction? Totally works, says that that's 7. Let's do division. 10 divided by 3 is 3. So you will notice that it gave us a whole number when 10 divided by 3 is really what? 3.33333 repeating. So I'm going to cover that later in this section. You'll learn how to get into decimals and stuff like that. But we can also do multiplication, right? So that's really easy with Swift. If you ever have some math problem that you're trying to do, you can totally just type it into a Swift playground and get awesome answers. And if you ever want to, do you remember order of operations from school? It's not a big deal if you don't, but like if you have 10 times 3 plus 5 divided by 80, and then, plus 6, like there's all these different kind of crazy computations, and there's an order about which this should be run in. Like I think if the multiplication and the division happens first, then you do the addition. Well, if you put parentheses around stuff, like if I add a parentheses around this 80 plus 6, it will ensure that the stuff in here happens first. Then it will do this division. And so if you ever want to change the order of things, you can always put parentheses around stuff. Let's see how this changes our answer. Ooh, now it's 0 here. But anyways, yeah, you kind of get the picture about how those parentheses work. So that's really basic math functions in Swift. Now I want to show you how you can incorporate variables into using math. So let's create two variables here. So I'm going to have one of them be age. That's kind of a classic example for us. I'm going to say age is equal to 27. Let's also get the age of my imaginary dog. So I'm going to say dog age is equal to 8. Okay. So if we wanted to see how many years older I am than my dog, I could do some simple math here and just say dog or age minus dog age. And this gives us the answer of, come on playgrounds, 19. Okay, so do you see how if you create these int variables, you can use them and just do kind of regular math with them? What are our ages together, right? Do some addition. We can totally figure those things out. So the other cool thing is that you can do some math with ints and then put them into a new variable. So let's say I want to know what my combined ages of the dog, of my dog and myself, and I want to put this into a new variable. Well, I can say var total age is equal to this math problem, right? And now anytime that I type total age, you can see that the value of total age is now 35. Right, so this, I could have said, 27 plus 28 here, but instead I'm using these variables, and it's cool because, if I change my age to like 20, I was not expecting that. Let's go ahead and reopen this playground. If I change this to 20, let's see what Xcode gives us. You can see it's now 28. If I change this down to 10, this should go to like 18. Yeah. Totally the same thing there. So you can kind of see how you can use math with variables, but also assign them to something new, right? Like if I say var total age is equal to age plus dog age, now I have this new variable total age, which represents whatever the sum of these two things are. So there you have it, kind of some basic math and also how we can work them through with variables. I've got an exercise for you. Let's keep moving. In this lecture, I'm going to teach you about two different new types. And do you remember what types are, right? Strings a type, int's a type. It's just something that we can put inside a variable. So let me just get back to an old example that we had where we had var age. I'm going to say var name as well. Set this equal to something like Nick. And I'm going to do this type annotation to say that this is a int. This thing here is a string. And then now I'm going to introduce to you first something called the float. So what is a float? A float is a number, just kind of like an int is a number, but a float represents a number with a decimal. Okay, so a big difference between ints and floats are ints have to be whole numbers and floats have to, or don't have to have, but they can have a decimal with them. So I'm going to say var float. No, I have to give my variable a name first. So I'm going to do, I thought this would be kind of funny. I'm going to represent my weight via a float because I want to know specifically how many pounds I weigh. I don't know my weight in kilograms, but I do know in pounds. Crazy US system here, but so weight, this is going to be a float. So now I can say my weight is something like 192.67, okay? And you can see I can use these decimal points, and it looks like I have to capitalize float here. There we go. That should fix things. Yeah, you can see that this is valid code. Now, you'll notice if I try on this int, if I try to say like 10.5, I get this whole big error because it's saying, whoa, you said this thing was going to be an int. Int have to be a whole number. You can't do this. So if I go back to 10, that will work. Now, with floats, you can give it a whole number like this, like 192. That's totally valid. It will just kind of reference it as, like 192.0. But you may be wondering like, well, why are these float things important? Well, remember when we tried to do some math and we said 10 divided by 3 and it gave us the answer of 3. Well, look what happens when we do 10.0 divided by 3.0. We get 3.33333, which is the actual answer that we wanted, right? Like this actually represents what it was we were trying to do. So it's important to note if you're working with just ints, like if you do some sort of math problem with just ints, you will get an int answer, which means it will round down. And if you work with floats, then it will also do that. Now, you may be wondering, okay, you said you were going to talk about floats in doubles. what's a double? Well, a double is a float, but just it can go out to more decimal points. So I'm going to show you an example here. So if I have my weight and I say it's 192 point, and I'm just going to go buck wild here, type like a bunch of numbers, blah, 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 blah. So this is like a huge decimal thing, right? So if I use a float, this will go out to 192.7548. And I'm going to copy weight here, and I'm going to paste it a few times just so you can see the output on the right. Like, it really is just a few decimal places off of that. It just kind of disregards all the other things here. Now, if we use a double instead of a float, you can see we get more precision. It says, okay, I will take more than just like, the first couple of decimal points there. So that's the difference between a float and a double. Both of them are numbers that have decimals, but a double is more precise than a float. So you may be wondering, well, why would you ever use a float? Well, there's some situations where if you're writing a program that needs to be extremely efficient, there's certain situations where a float would make more sense than a double because maybe your code would run faster. But I promise, I have been programming for 5 years, and I have never run into a situation where I absolutely needed a double versus a float. Like, I know there are people out there that have those situations, but if you're just kind of making an app, I've worked for companies, I've made apps for myself, it's never become an issue. Like, that is not something we have to deal with. So, in my recommendation, I would always use doubles, and in fact, that's what Swift wants you to use. Because if you say over here, if you say I'm going to make a something called weight, and I'm just going to set it equal to a number with a decimal, you can see that it defaults to a double. You see all the extra decimal places on the air. It's a double, not a float. Only if we specifically specify that we want it to be a float, that's when it shrinks it down to something. So I think you should always use doubles. That's what Swift will default to. Like, even if I say up here, let's get rid of this so I can now say, age is 10.5. It may look like a float because it's short, but this is actually a double. This age thing here is a double. It's just what Swift defaults to. So if you ever need to have a number with decimals, you want to use a double, you can use a float. I mainly tell you so that if you're ever coding and you see a float somewhere, you're like, oh, I know what that is. It's not something that's foreign to you, but I think you should always use doubles. So now I'd like to talk about how we can take ints, floats, and doubles and make them all work together. And to show you why we need to learn that, let's go ahead and clear out some things. I'm going to make like my weight just something like 192.75. Let's get rid of the string example. And let's make age a int again. So here you can see we have a variable named age, it's an int, and we have a variable named weight, and it's a double. So if we want to do math with these two things, look what happens if I say age times weight. Okay, I do these two things, we get this big error from Xcode. So let's go ahead and click on it, see what the problem is. It says binary operator star, the multiplication thing, cannot be applied to the operands of type int and double. Saying, hey, you can't multiply two things if one's an int and one's a double. They either have to both be an int or they both have to be a double. So you might be wondering, well, how do we get around this? Well, we can either make both of them ints or we can make both of them doubles, but somehow we have to make both of them the same if we want to be able to do multiplication. I think the same is true for division. Let's check. Yep, doesn't work. Let's see if we can do addition and subtraction. Yep, nope, we get the same problem. It's like, so really with any math that you're doing, you got to make sure that all the different types line up, that you're using all ints or all doubles, whatever. So let's start with saying, let's do the multiplication here and say, I want to multiply age and weight, and I want the result to be a double. So you have to decide what you want your result to be. If you want your result to be a double, then you want to change all these things into a double. And if you want all of them to be ints, then you should change everything to an int. So let's start with a double. The first thing that we could do very simply is just change this from saying 10 to like 10.0, and that will automatically make it a double, and suddenly this works. Or if we wanted to, we could say, put a colon here and say age is now officially a double, and look at that, it works. But let's say you're in some situation where you have an int, you have a double and you want to do math, but you can't go back and change these things. Maybe it's a bigger program and you don't want it to be, age really should be an int, but you just need to do some basic math real quick. Well, what we can do is if we type out in front of age, we're going to type capital double, and then we're going to do a parenthesis at the beginning of age and then the ending parentheses on the other side of age. Guess what happens? It takes this age, which is an int, and it turns it into a double. So this, by doing this, I'm just going to copy this line of code, put it down here. This essentially takes, oh man, Xcode's being real buggy. Let's open that up again. If you put double parentheses and then put an int inside of there, what it will do is take whatever that int was and turn it into a double. So you can see, even though this was an int, makes it a double, now this math totally works. And we can go the opposite way. So I'm going to delete this. We should get the error back from Xcode saying, oh, these are two different things. I can turn this double into an int. So if I do capital int here, all right, change that. Well, look what happens. Da-da-da-da. Come on, Xcode. It turns weight into an int. Now you might be wondering, does this round up? Does it round down? Well, you can check if you want to. Just go ahead, copy this code, put it on a new line. You can see what it does. So it's looks like it rounds down, even though this is like 0.75. I think even if we change this to like 9999, yeah, it will always round down to the next one. So anyways, that's how you can convert things. And again, this goes for, both doubles and floats. You could turn things into a float if you want to. And in fact, we could turn both of these things, this int and this double, into a float if we wanted to. So I'm going to change this to float. I'm going to put a float around this one. And this will actually give us back a float. You can see this 192.99999. So there you have it. Remember, if you're doing math with, ints, doubles, anything that's not the same type, at some point you have to bring them all into the same type and you will get an answer in whatever type you turn them all into. So maybe an easy way to do that is to just permanently change this at the beginning to be of the same type, but you can temporarily kind of morph things. And it's important to note when, for example, here, when I say, let's change, I think this will go better if you see we do like, let's turn this double into an int. So I'm going to say int parenthesis and put weight inside of there. Remember, weight is a double, right? So it says this is 192. It has not changed this variable weight at all. Okay, so, and if I type weight down below here, you will see it's 1.2999. All that has happened here is when I say int and then do a parenthesis on the weight, it just says, oh, okay, take whatever inside of weight, turn it into an int, and then it just kind of, shows this out here on the right. It's not like it changed the value that was inside of the variable. It did not change the double that was in here. All it did was, okay, popped it out, turned it into an int, and then, shared it so that you could use it to maybe do some math or whatever, but weight has not changed. If we wanted to kind of permanently change weight into an int, you would think, well, maybe we could do this. We could say weight is equal to weight when it becomes an int. But the problem with this is we have already specified at the beginning here that weight was going to be a double, right? By saying putting 192.999, since this is something with a decimal, Swift turns this into a double. We cannot change this back into an int. And so I just want to make sure you understand that when we say put like int around something or double, it does not change the variable inside. It just temporarily takes that value and turns it into something. Okay, so go ahead, work through the exercise, and then we're going to dive into some advanced math. Woo! So here we are at the last lecture of this section. I want to teach you about some advanced math stuff. So first I want to dive into floor and ceiling. So let's say you have a double or a float and you're trying to either round up or round down. Well, floor or ceiling allows you to do that. And in order to do this, we have to write a little bit of code at the top of our program. We're going to type import foundation. Okay, and you might be wondering, well, what's foundation? Foundation is it's called a library of code, but it's code that Apple has written to allow us to do some new things with our code. It's kind of like extra stuff that allows us to do more with Swift than just the original base version of Swift. So in order to do some of these more advanced math things, we need this. And trust me, to get into the really, really advanced math stuff, other people, not just Apple, have created these really cool libraries that you can do awesome stuff with. But for us, just type import foundation up here at the top. Make sure you have the capital F. then we can do some of these cool things. So first, let's go ahead and make some sort of double. I'm going to bring back that weight example, and I'm going to use create a constant this time. I'm going to say let weight be equal to 192 point something, right? We have some sort of double here. Let's make sure it's showing up there. Looks good. Okay, and now we can use these things called floor or ceiling to round this up or down. So you'll see if I start typing floor, in this auto suggestion box, we have this what's called a function, but it says floor. If you click on this, you'll see it's looking for you to put some sort of double in between these parentheses. So I'm going to put in weight right inside of here, inside of the parentheses, and look what happens is it rounds that number down. Okay, so it takes whatever weight was, and then it rounds it down. So it sees, oh, okay, 1.9 or 192.6, whatever. I'm going to round that down. Again, even if this is like 0.99999, it will round it down to 192. So there's also a different function that we can use called ceil. Okay, got to make sure I spell that right. And what ceiling does is it takes a double and then it puts it up one rather than rounding down. It rounds up. So to use this one, you just type ceil, a parenthesis. I'm going to put weight inside of here, and you can see that this rounds it up to, come on, Xcode. It's going to round it up to 193 once this shows up. There we have it. And it doesn't matter what this is. If I change this to 192.3, it'll still round this one down, round that one up. But you'll notice if I make it 192.0, well, it'll stay at 192 just because it's this. It's not like ceiling's going to bring it up to 193. So as long as it's not 0.0, if it's 0.00001, I keep getting a crash from Xcode. It's probably, I'm on an early beta version. I think that's why it's crashing. But you can see even if I have 192.001, it will round up to 193. Okay, so there we have floor and ceiling. Now I want to talk about how to do exponents with Swift, right? Like if I want to take, if I want to square a number, right, multiply it by itself, we do pow, and we do one parenthesis, and then you have to put your first number on the left. So I'm going to do let's say I want to take the number 5, then you do a comma, and then you say what power you want to take it to. So if I do it to the power of 2, that means have 5 multiplied by itself, 2 times. So 5 times 5, you see the answer is 25. If I change this to 3, this is like saying 5 to the 3rd power, and it's 125. If I multiply this to 4, it just keeps going up. Watch what happens when I do 10. It's like some huge number. Let's see what 100 is. Yeah, wow, can't even fit on the screen here, huge type of thing. But this is how you can raise things to a certain power. So again, if you want to square stuff, just keep this at 2, and then this number you can have be whatever it is that you want. Okay, so that's how you can do exponents and raising things to a certain power. The last thing I want to show you is something called plus equals. So if you ever have I think this is kind of a great example of how this plus equal things is kind of cool. So let's say I have a variable called wallet, okay? And it's equal to, let's say I start out with no money in my wallet, right? So I'm broke, I don't have any money in my wallet. Let's say I want to add some money into my wallet. Well, what I could do is I could say, wallet is now equal to 50 if I got $50 or something like that. But what we could also do is just say, wallet is equal to whatever wallet was originally plus 50. And you may be thinking, well, is that really that important? What kind of difference does that make? I could have just said equal to 40. But let me show you how this could really become a thing. So if we just said, wallet's equal to 50 because I got some money from work, and then, all of a sudden I bought some snacks at the store. So now wallet, let's say the snacks cost $5. Now the wallet's equal to 45. Then I went and bought a car wash or something like that. That's $10. So now I'm at 35. It's kind of awkward just to see this number start at 0, then go to 50, go to 45, 35. If we're looking at this code, we have no idea why the wallet is changing. But if we could say something wallet is equal to wallet plus 50, it's like, oh, well, $50 was added here. And then if we say wallet is equal to wallet minus 5, we say, oh, we took $5 out of whatever the wallet was. Got to make sure it's wallet, not waller. And then for this last one, we can say wallet is equal to wallet minus 10. So what I want you to notice here is what we're using is we're kind of using whatever the value of wallet was and then kind of updating it to something new. So here we're saying, okay, wallet is equal to wallet plus 50. Well, wallet is 0, so 0 plus 50. Now wallet is equal to 50. Then here we're saying, all right, wallet's equal to whatever wallet was before, which was 50, minus 5. So now wallet's equal to 45. And then here we're saying wallet's equal to whatever wallet was, 45 minus 10. So now it's 35, okay? So this is kind of a neat way that you can update the value just by adding on some or taking a little bit off. And this is a very common scenario in programming. So Swift has this neat little thing where, I don't know what that accent was, but where you can say wallet is plus equals 50. Okay, so this line of code right here, this wallet plus equals 50, is the same thing as saying wallet is equal to wallet plus 50. What it does is it adds 50 to whatever is already inside of wallet. See, and so if I go ahead and delete this, you'll see it will go from 0 to 50. So, and like with these, I could change this. There's a minus equals, so I can just do wallet minus equals 5, which will just take off 5 of whatever wallet is. Let's do the same thing here. We're going to do a minus equals. So now it goes from 45 down to 35. So it's a really nifty way to just kind of update the value of something to say, oh, I want to add 50 on here. I want to take off 5. I want to take off 10. It just kind of makes our code a little bit easier to read. So there you have it. There's the advanced math stuff. Like I said, some of the really, really advanced stuff, if you want to get into that, there's these other cool libraries that you can get into. Contact me if you want to see those. I can give you links for that and stuff. But that's all we have for math. Let's go to the outro. Well, exercise for you first, then the outro. Well, I hope you enjoyed learning a little bit about math in Swift. This should give you a really nice foundation so you can move forward in the course. You're doing really great. If you have any questions or comments, please let me know. I want to make sure this is an awesome class for you and that you're learning. Please hit me up. But if you're feeling good, ready to rock and roll, let's move on to the next section. Welcome to the section on Booleans and if statements. Now, Booleans, these are just another type, just like strings, ints, doubles, floats. We're adding one more to our knowledge, and that is Booleans. Now, if statements, these are very exciting. In my opinion, this is where our code starts to become alive. It makes decisions now, and then depending on certain situations, it'll either run this code or that code. It's pretty exciting stuff. So let's go ahead and dive in first with Booleans. So let's dive in and start learning about Booleans. And like I said earlier, Booleans are just another type. Remember, strings, ints, floats, doubles, all of those are types. But the interesting thing about a Boolean is there's only two possibilities that a Boolean can be. It can either be true or it can be false, which is very different from other things, right? Like a string could be any combination of letters, words. A number could be like negative something, positive, whatever. But a Boolean can be true or false. That might not make a ton of sense. I know when I first learned about Booleans, I was like, okay, what does that mean? But I think through an example, you'll come to understand this. So let's make a Boolean that represents whether it is sunny outside or not. Now, you could get into the argument about, oh, during sunrise and sunset, it's, maybe not exactly sunny. We're just going to say it's either sunny outside or it is not. We're going to make a Boolean that kind of represents that situation. So here I have some examples of an int in a string, and I just want to have a Boolean next to it to just reinforce this is another type. Okay, so I'm going to say var sunny, because I want to have something that represents whether it's sunny or not outside. And we're going to specify that this is going to be a Boolean. To do that, you just type bool, B-O-O-L, and we're going to say this is equal to false. Okay, so this would be if it was not sunny outside. And if we wanted to, we could say that it is sunny outside by setting this equal to true. Now notice with a Boolean, if you set it to true or false, there's no quotes around this. Like if we try and add quotes here, it's going to say, whoa, you're trying to turn this Boolean into a string, which a Boolean is not a string. It's either true or it is false. Lowercase true, lowercase false, just like this. And this is the crazy thing. Those are the only two options for a Boolean. Like with an int, this could be some huge number like this, 1 million something, I don't know. It could be negative this number. Anything in between, like it could be just straight up 0. It doesn't matter. Like there's tons of numbers that an int could be. And with a string, there's like almost infinite combinations because it could be Nick, it could be Nick E. Gosh, Playground keeps dying on me here. But I mean, we could just go through the alphabet: A, B, C, D, E, F. I mean, we could put all the emojis on there. There's like almost infinite possibilities for the different strings out there. But a Boolean literally has two options. It's either true or it is false. Like, there's no way for us to show all the different possibilities for a string or an int. Like, not all the books in the world could contain those. But for a Boolean, you can. It's either true or it's false. Like, that is it. Those are the only two options there. So you don't have to specify here that it is a Boolean. You can simply just say, you know, Sunny is equal to false. And just like any other variable, we could change this later. So we could say Sunny is now equal to true. You can see it switched from false to true. This is completely valid code. Just want the playground to update so you can see that. Yeah, you see how it changed. And we can change this thing to a constant if we want to. That's totally fine, except now we can't change the value. But yeah, there you have it. A Boolean is just a type like the others. Let me go ahead and put the little colon here so you can see, right? A Boolean is true or false. Now, I probably realize this doesn't make a ton of sense. You're like, well, what meaning does this have? I maybe understand this. A Boolean can be true or false, but where would I use this? And if statements are all built off of Booleans. So I'll show you why they're important here in the next lecture. So first do an exercise here that I have for you. Then let's move on to the really fun if statements. So here we are, the lecture about if statements. I think if statements are really cool. They bring our code to life. Let's go ahead and just dive into it with an example here. So I'm going to delete the code that we have earlier so we can kind of start fresh. And I want to start by defining what an if statement is. So an if statement works with a Boolean to say if a Boolean is set to true, run some chunk of code. And if it's set to false, then we won't run this chunk of code. It's really as simple as that. And the reason I say this brings our code to life is now our code can kind of start making decisions to say, hey, if this Boolean, you know, is true, then we're going to run this code. If it's not, then we'll just keep on going without it. Okay. So let's go ahead and create a Boolean. This is kind of the example that I want to set up. We have a wallet and, you know, we're waiting for payday so that we can get some money so we can go get some food from like 7-Eleven or something. So we want to have an if statement that says if today is payday, then go ahead and add like $100 to our wallet. If not, then don't add anything to our wallet. So that's just kind of the situation that we're going to set up here. So first we need to make that Boolean that decides today whether today is payday or not. So I'm going to say let payday, let's do capital on day, be equal to false. We'll start off by saying we don't have a payday. And let's also create our wallet. So I'm going to say var wallet. We want to make sure wallet is a variable because we want to change the amount of money in there over time. And initially it's set to 0. We don't have any money in our wallet. Now let's make our very first if statement. So to create an if statement, just type if space, then we have to type, give some sort of Boolean here. So let's use this payday constant, which is a Boolean. So we'll just say if payday, like that. And we're going to do a curly bracket. And if you do the left-sided curly bracket and then just hit enter, Xcode in the playground will automatically add the follow-up curly bracket there. So what's going on? Well, this if statement says if this payday is true, then anything that's inside of these square brackets, so, you know, if we just did like a bunch of lines here, like all the code that's in between these curly brackets, it will get run if payday is true. But if it's not, then that code will not get run. Let me make sure this is wallet, not Waller. So we only need one line in here, and all we're going to say is if it is payday, then we're going to say wallet plus equal 100. Remember when we learned that plus equals thing? And then I want to show wallet down here just to make sure you can see what it's equal to. So right now, in our situation, payday is equal to false. And our wallet is initially equal to 0. So our code runs these two lines. It says, okay, I'll make a constant. I'll make this variable. Then it gets to this line and says, if payday is true, run this code. And it goes and looks at payday. Oh, payday is false. So it doesn't run that code. And we can see that wallet is equal to 0. We have no money in our wallet. But watch what happens when we say payday is true, meaning today is payday, we change that to true, and now this code gets run. Now it says, oh, if payday is true, then it's going to run the code that's inside these curly brackets. The wallet will be plus 100. You can see now there's 100 in the wallet. So just by changing this guy right here, we can say either run the code that's in there or not. And like I said before, you can have multiple lines inside of here. Like, let's just copy and paste this one a couple of times. Like now you can see it went up 100, 200, 300, 400. By the end, we have $400 in our wallet. I guess we got paid 4 times. But with the if statement, you start it here by saying if space, you give it a Boolean space, and then this is the code that says, all right, if this Boolean's true, run the stuff inside of here. If it's not true, then just go on and keep rocking, okay? Because watch this. I'm going to do another line right here where I say wallet plus equals 10, just so you can see. Like right now, because payday is true, the code will run through. It says, oh, if payday is true, oh, it is true. It'll say wallet plus 100 plus 100 plus 100, so it has 400. So it does all this code, and then it says, oh, and I'm going to add 10 onto that 400. Now it's 410. And if this is set equal to false, the code will, get to here to this if statement that says, oh, payday is false. It skips all of this. None of this code here is run. Absolutely none of it. And then it just keeps on running the rest of the code down here. That's the way that Swift code works. It runs from top to bottom, and this if statement, if it's not true, if it's false, it'll kind of skip that and move forward from there. So there's a brief taste into if statements. Maybe you're starting to see, oh, these are kind of cool. I'm going to make sure you do an exercise with a situation similar to this. Then we're going to dive deeper to show how if statements are even cooler. In this lecture, I want to take if statements to the next level by talking about comparison. And we can use comparison to make Booleans, which in turn we can use with if statements. It's going to be really cool, trust me. So let's go ahead and kind of wipe out some stuff that we have. And I'm just going to make 2 constants. One's going to be called A. I'm going to set this equal to like 5. And one is going to be B, and I'm going to set this equal to 8. So basically we just have 2 numbers, A and B. A is equal to 5, B is equal to 8. Simple enough, right? So I'm going to show you how we can use comparisons to get Booleans. Okay, so let's say I want to know which is the bigger number, A or B. I can say A, just type this on a new line with Swift here, A space, then do the greater than sign, and then B. And look at this line of code. So this is asking, is A greater than, and if you're ever wondering, like, is it greater than or less than, just know, like, the bigger side of this thing is pointing to the one that you're asking, is this bigger? So we're saying, is A bigger or greater than B? And look at this, it gives us back a false, right? Because A is not greater than B. But if we switch this around and say, is A less than B? It says true. Yes, 5 is less than 8. And look what happens if we make 5 bigger than 8. We make it something like 10. Well, now this gives us back false. And remember, this false, this is a Boolean. All right, and there's some other cool comparisons that we can do. So it's not only greater than or less than, we can do greater than or equal to. So this is saying, hey, is A less than or equal to B? No, A is greater than. But now if I change it to 8, this is both, A is equal to B, so it satisfies as true, but it also could be less. It could be like 7, it could be 3. Just as long as it's equal to or less than 8, this is going to end up being true. Now we can do this, do these comparisons with more than just numbers. And one more thing I should note here, you can just straight up check if 2 things are equal to each other. Like, is A equal to B? In order to do that, you have to use 2 equal signs, right? Because if we just did 1 here, we're just saying, hey, I want A to be equal to whatever B is. That's not what we're looking for. What we want is 2 equal signs to say, hey, are A and B exactly equal? No, they are not. But if I change this one to 8, you can see, oh, both are 8. Now it gives me back true. So we can also do some comparison with strings. So I'm going to say, let's make, this one doesn't have to be a constant. So I'll make a variable. Let's just do the classic name one. I'm going to set name equal to Nick. So I can do some comparison to say, is name equal to Nick? And if both are spelled exactly the same, I will get a true. But look what happens. I say, is Nick or is name equal to Sean? oh no, it will give me a false saying, you know, these two strings aren't the same. So with these comparison things, it's not just with ints or numbers. We can also use strings to check if things are equal to each other. If you want to see things, if things are not equal to each other, you put an exclamation point in front of the equal sign of this saying, hey, they're not equal. So anyways, this is just showing how when you compare things, you will get back Booleans. So this is where the real magic comes, in that you can use these together with if statements. Oh, it's so cool. So now I'm going to say if A is greater than B, then do the following code. Sometimes if statements in other programming languages, they're referred to as if-thens, because it's saying if this thing here is true, this Boolean, which when you compare things, it gives you back a Boolean, so it really is a Boolean. If this is true, run this code inside of here. So I kind of want to go back to our payday example and really like spiff things up. So I'm going to say let payday be equal to false. I'm going to do my capital day there. That's a good convention with Swift because it's a new word. Let wallet be equal to 0. And what I'm going to do is bring back that other if statement that we had. We're going to say if, you know, payday, then we are going to add some money to the wallet. So we'll say wallet plus equals 100, right? You know this code. You're like, this is totally fine, whatever. Now I'm going to do a new if statement that says, you know, if, oh, what do we have wrong here? Oh, we can't have wallet be a constant. We need it to be a variable, okay? So now, you know, it will decide, hey, if it is payday, we're going to say, we'll add $100 to this. And then let's say we want to buy something with the money in our wallet. We can do an if statement to see if we have money in our wallet. So let's say something costs like $5 or something. We can say if wallet is greater than or equal to $5, then run the following code. Like we'll say wallet minus equals 5. Okay. So look at this. I think this is so cool. So if payday is true, our wallet starts out with $0, but because it's payday, we get $100. Then it's saying, hey, I want to buy something. If the wallet has at least $5 or greater than that, then we're going to buy something for $5. Now we only have $95 in a wallet. But look what happens when I set this equal to false. Okay. This code never got run because I didn't have $100 in my wallet, and or because it's not payday. And then this says, is wallet greater than or equal to 5? Well, no, wallet's equal to 0, so this code never gets run. Do you see how the code is coming to life? Like, this is amazing. Our code can make decisions based on what's happening. And so you can kind of see here, like, by using these comparison things, we can do some pretty cool stuff. So let's go through like one more example where, you know, let's add something on here like, let name be equal to Nick. Okay, so we're going to say like if your name is, if it's some certain name, you get like a special discount or something, right? Or like on your money or whatever. So we're going to say if, in fact, let's do this. Let's put this if statement inside of here. So we're going to say if you have more than $5 in your wallet and if name is equal to, remember you got to have two equal sign, if name is equal to Sean, let's do our little curly bracket thing here, then we are going to say wallet minus equals 3 or something like that. So I'm starting to realize this is actually a pretty garbage example, because if I switch this thing to true, not only does it take out let me switch this thing to Sean. If it is equal to Sean, not only does it, you know, charge you $5 here, but also charge you $3. So I guess this is like a Sean tax or something like that. I don't know, but I'm just trying to show you, look, you can use if statements with comparing strings, comparing numbers. But yeah, I mean, it really does make your code come to life. And I think it's really neat. Like this example, I think is so cool. Like, oh, if it's payday, give them money. Oh, now that you have money, if you have at least $5, you can do this. So let's say payday now is only equal to like $4 or something. Look, even though it's payday, this code does not get run because the person doesn't have at least $5 in their wallet. They can't afford whatever item it is that they're about to buy here. If I set this equal to 5 though, well look, it does. It empties out the wallet completely. And if it's $6, then they got $1 left. So yeah, I hope you kind of enjoyed seeing how you can use these things together, and really the code's coming to life. So we're just going to dive deeper and deeper into this in the next lecture, but let's stop doing exercise. Make sure you're comprehending what we got here. So this one is going to be a really quick lecture. All we're learning about is something called else, and it's really natural extension of the if. And let me show you right here. So let's create a whole new example. I'm going to create a person's age. So I'm going to say let age be equal to something like 27. That's my age, right? So what we want to do is make a situation that determines whether the person is a minor or an adult. So in the US, if you're 18, you're considered an adult. If you're younger than that, then you're a minor. So let's make an if statement to check this. So we'll say if age is greater than or equal to 18, then we're going to just make a string inside of here that says adult, okay, and looks like I'm 27, which is greater than or equal to 18, so it says adult. And well, how do we determine if the person's a minor, right? Like if I say change this to like 15, well, we want to have some sort of output here that says minor or something like that. So what we could do is we could create an if statement here that says if age is less than 18, then we are going to create a string that says minor. And we check this out, and oh, okay, look, if it's 15, it's that. But as long as the person's 18 or older, so let's try out 18. Oh, it's 18 and it's an adult. So this is fine. We can have the two if statements here, but you can see that this one is the complete opposite of this. This one says greater than or equal to 18, which means if it's 18, 19, 20, whatever until like infinity, this will get run. But as long as it's less than 18, which is basically 17, this one will get run. So what we can do is something called an else. And so let's get rid of this for a second. What we're going to do is after this curly bracket, the ending one, we're going to do a space and say else, then do another opening curly bracket and hit enter. Whoa, so what's going on here? This if statement says if this Boolean here is true, remember when you compare things, it gives us back a Boolean. If this thing is true, run the code inside of these curly brackets. The else says else, meaning if not, if this thing is false, run this code. Okay, so now you can kind of say, if it's true, do this. If it's false, do this. So it's not just whether, okay, if it's true, do this. If not, nothing happens. You can say, well, if it's not true, then I want this code to run. So we can put inside of here minor, and this is exactly the same output that we would have gotten as the other one, right? Like if I say 17, now it's a minor. If I change it to 1 year old, that's a minor. If it's 100, now it says adult, and you can kind of see how it does the flip there. So that's really all you need to know about else, is that after an if statement, after that curly bracket on the same line, do space else, and then start another pair of curly brackets. And all this is doing is saying, if this Boolean is false, run this code. If this Boolean is true, run this code, right? Like it just, if statements will make that decision to say either do this one or the other one. That's it for else. Go do an exercise on it. We'll keep moving. So here we are at the last lecture of this section, at least the last one. That you're going to learn something new. Of course, I've got an outro for you. And with this one, we're going to be learning about and or. These are things that we can put into our if statements to make them that much more robust and awesome. So I'm going to kind of take this example that we have right here and tweak a little bit to teach both and or. So have you ever been to an amusement park and to go on a ride, you have to be a certain height? Well, let's say that we own an amusement park and we want to know a couple of things, like whether we let someone on the ride or not is dependent on maybe say both their age and their height. So let's go ahead and kind of set up this hypothetical situation. So we have someone's age. Let's also create a height for them. So we'll say height, and because I'm American, I'm just going to measure this in inches. If you're the rest of the world, you will use centimeters, but let's say, we want people to be at least 5 feet tall, so that'll be 60 inches. We want them to be at least 60 inches. So what if we decide, we are only going to let them on the ride if they are both over 18 and they are above 5 feet. So they have to fulfill both requirements. Well, if they can, then we want to, let's make a third thing here. We're going to say can ride. So right now it's set equal to false. All right, but if they fulfill the requirement of both being older than 18 and above 60 inches, then we will allow them to actually ride on the ride. If not, we're going to keep this thing as false. So if we're going to set up an if statement for this, we can say, if the age is over 18, right, we have this one, then we can do another if statement inside of this that says, if the age is greater than 18 and if height is greater than 60, let's do, just greater than, so you have to be at least 61 inches. So if height is greater than this one, we're going to set can ride equal to true, right? And if this is not the case, then we'd want to set it equal to false. Well, it's a little bit tough because if this one's not true, we'd have to say else. We're going to say can ride is equal to false like this. But what happens if they're older than 18 but under 5 feet? Well, then we never get a chance to call false here. It's a little bit tricky. But even if that weren't the case, this is just kind of messy to have these nested if statements, to say, if the age is greater than 18 and if the height is greater than 60, then we want can ride to be equal to true. What we can do is use something called an and to combine these to be both in one line. So what I'm going to do is just cut this right here, okay? Delete this code, and then on this line that says if age is greater than or equal to 18, I'm going to do 2 amperstamps. So this should be on your keyboard. If you hold shift and hit the 7 button, these little amperstamps, they mean and, right? So you do 2 of these in a row, and now you can add another Boolean into your if statement. And for us, we're going to put in this one where it says, height is greater than 60. So what happens now is it checks, hey, if the age is greater than 18 and the person is greater than 60 inches, then we're going to say can ride is equal to true. So right now the person is older than 18, but they're exactly 60 inches, so they can't ride the ride. But look what happens when I make this 61. Well, yes, now it's true. And so what's important here at the and is both of these situations have to be true in order for this thing to move on, right? Like, even though if the person's tall enough, if they are only 10 years old, now this code does not get run because, oh, hey, the person wasn't 18 years old. Well, then this can't happen because both things have to be true here. So the and kind of creates a situation where it says, okay, the thing on the left and the thing on the right both have to be true. Both Booleans have to be true. And if that's true, then I can run the code inside of here. So then, we could easily add an else onto here and say can ride is equal to false. All right. So this is one situation, right? Like this is, okay, we're saying we want them to be an age and a certain height. Well, what if we change our minds and we say we want the person to either be 18 or older, or they just have to be tall enough. So it doesn't matter which one they satisfy. It's okay if they satisfy both, but they just have to satisfy one or the other situation. Well, that is called an or, and it kind of just comes out through talking in English, right? Like the person has to be 18 and taller than this, or the person has to be 18 or taller than this. Like it's really natural here, but to do the or, we're going to delete the 2 amperstamps and we're going to add these 2 solid lines. Now, I know at least I don't use these all the time on my keyboard. They're a little bit hard to find. They should be just above the return key. If you hit the shift key and hit the backslash, you'll get these like straight up lines. And so this represents an or. So it just says, if one of these Booleans is true, then run, the code inside of here. So if we look at this, the person is not older than 18, but they are over 60 inches, so this code gets run. Now, if I bring their height down to something like 40, well, now they don't satisfy either of these, and so the else gets called here. But if I change the age up to something like 20, okay, now the can ride is set equal to true because it says, oh, okay, at least one of these things was, true. This age is greater than 18. Okay, that's true. I will run the code inside of here. All right. So to just kind of simplify this, to really make sure you're understanding the and the or, I'm just going to set up 2 situations. I'm going to say first if true and true. I'll just put something in here. I'm gonna put true. I'll just do an else here to say, in all caps, false. Okay, I'm just gonna make sure you really understand the difference between the ands and the truth. So here you can see with the and, if both of these Booleans are true, this gets run. If this one happens to be false and that one's true, well, neither of them, because one of them is not true, then all of a sudden the else gets called, and now it's saying, you know, this whole total thing is false. If both of them are false, of course, this one's going to get run because it needs both things to be true. And if this one is true, that one's false. Make sure that's lowercase. Still, this one gets run. With ands, the only way that the true, like it all equals true, meaning it runs this code here, the if statement's true, is if both the thing on the left and the thing on the right are true. Okay? Eesh, horrible typing, Nick. Come on. So that's with the and. Now with an or, if both are true, awesome. That means everything's true. If only one of them is true, like the one on the right's true, okay, well then still everything's true. And if we change this one to be true and this one to be false, well, still one of them is true, so this one won't get run. Only situation where or is false is if both of these things are false, then you can see it goes down to this one. And if you really want to check, make sure you understand this stuff, we can actually get rid of this whole if statement thing here. Just have this, and you can see on the output to the right of the playground, it will give us either true or false. So if I change this thing to true right here, you can see, oh, we have true because with an or, only one of the things has to be true, and this code will run. Xcode took a little bit, but there it is. You can see that. So this is just another way that Playgrounds makes it really easy to learn here. So there you have it. Like I said, that was a bit more advanced. Hopefully you do well with this exercise. If you need any help, ask a question. I'll be there to help you, but good luck, and we'll go wrap everything up after the exercise. So in this section, we packed a lot of information into your head. We covered Booleans. Now we know yet another type. I think we know 5 types now. And you learned about if statements, which are crazy cool. Like I said, they really do bring your code to life. I hope you kind of saw how things and situations change. Again, I love that wallet example. I think it illustrates things really clearly. But if you have any questions, please let me know. I'll be there to help you. And if not, let's keep moving. In this next section, we're going to learn about comments and prints, which should be a little bit of a lighter section. I know this last one was kind of heavy, so we'll kind of take a quote-unquote break with these things, but then after that, we'll keep on moving on with some really interesting stuff. This section is about comments and print. Now, conceptually, both of these topics are pretty easy to comprehend, and I put them in this part of the course because with that if statement section, we went pretty hard. We were getting into some advanced stuff there, like more than we had done before, and I kind of want to give you a little bit of a break mentally, and then after this, we're going to dive into more and more advanced stuff and just keep rolling with this Swift stuff. I'm so proud of you. You're doing great. Now, comments and prints, like I said, easy to understand, but they are still important. So good things to learn. Let's go ahead and dive right into it. Let's kick things off by talking about comments. Now, what is a comment? A comment basically is a way for you to write some text in your code that doesn't actually get run as code. It's a way for you to kind of leave some notes for yourself, or if you're working with other people on a programming project, you're leaving notes for them to see so that people can kind of understand what's going on, or if you need to come back and fix something but want to leave some notes about what it is you were working on, you can kind of do that. So I think an example will really help us here. Let's go ahead and open up our playground. I renamed mine to Swift 3. Who knows why? Remember, you can keep whatever name it is that you want. But here we have a nice blank playground. So let's say we have some code. I'd like to go back to kind of that wallet example, right? Where someone has a wallet and they start out with $0 in their wallet. And then at some point it's payday, right? So now we're going to say wallet is plus equals 100. We had $100 to the wallet. Then they decide to go buy some chips and a drink over at the local 7-Eleven, so they spend $5 on that, and then they decide, ooh, I really want to go get my car washed, and so they're gonna take 10 more bucks out for that, do minus equals for that, and then all of a sudden they get a bonus from work. They're like, hey, you were the employee of the week this week, you get $10 extra. Woo! So now we're gonna say wallet plus equals 10, right? So this is fine, right? This code, we know, okay, look, they got $100 and they lost 5, lost 10, got 10 back. But we have no context as to what happened. And now we can use comments to kind of leave some notes here so that if we were going to come back and look at this code, if someone else was going to come look at our code, they could understand more of what was going on rather than just randomly plus 100, minus 5, minus 10, plus 10. So let me show you how to make a comment. It's really easy. All you do is you do 2 forward slashes, and then you can type whatever the freak you want. It can be letters, it can be numbers. I think we can also do emoji in here, like whatever you want. You can just type whatever. So these slashes just say everything on this line isn't actually code. It's just a note that the person is going to write here, okay? Because notice, if I got rid of these slashes and it didn't turn green here, like if I just do this, well, there's this huge error from Xcode. It's like, I don't know what the heck like this thing is, HDUH, like, you know, there's a very kind of systematic part to Swift where, you know, if you're going to create a variable, it has to start with var. And then the only reason we put wallet here is because that's already a variable. Like you just can't type random letters and numbers out into Swift code. Like it has to kind of follow their format. So for this is a note. We put the 2 slashes here. It's a comment. Now it's totally fine. So let's apply this to the situation that we have here with the wallet. So we'll say, right above where they get $100, it was payday, okay? And then now when we say minus $5, we'll say got food at 7-Eleven. Then we'll go over here and we'll say got a car wash. And then we'll come down here to this line and say employee of the week bonus. Okay, so you can kind of see how using comments now, rather than just seeing, oh, look, the wallet went up 100, it lost 5, it lost 10, oh, and then it got 10 added. Well, now we have some context as to what's happening, right? Like, oh, it was payday, then they got food at 7-Eleven. Oh, then they got a car wash, and then employee of the week bonus. That's why it went up $10. Like, comments just allow us to like put some more information into our code that won't get run as code. That's the big thing here, is that you can type stuff that won't get compiled as code. And like I said, I think a really common use case that I use personally is when I'm coding something, and let's say I'm stuck on something, I can't get it to work. Like sometimes I will write a little comment and I'll say to do, and then I'll say can't get this function to work like da 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 da. Just whatever it is that I'm working on, if there's something I'm stuck on and I can't figure it out, I will kind of leave my thought process here in the comments, so that when I come back at a different time to try and fix this, I can understand, okay, these were the problems I was having. Because sometimes we work on coding projects, we come back, you know, a day later, a few days later, and it's like, oh, what was wrong here? Like, what was it that I was working on? So comments can be a great place to just kind of spill your brain out and then come back and understand, oh, this is what was going on. And especially if you're working on a project with multiple people and you're doing something that's like a little bit tricky or advanced, like a comment is a great way to say, hey, this is what's going on down below. So I get asked all the time by people, they're like, well, where am I supposed to use comments in my code? Like, you're not required to use comments in your code. I will say, as you start working on projects, if you're making like an iOS app, Apple Watch app, whatever it is, you will see comments everywhere. But don't feel a need to like put them in all the time. Just put them in when they make sense. And I think as you program more and more, you'll understand like, oh, this is a good time to use comments. This is not, like, so don't ever be worried that like you're not using comments enough. I think you'll understand when those situations are. So let's go ahead, do an example, make sure you can create your own comments. We're going to take things a step further with comments. In the last lecture, we learned about these comments, right, where you use the 2 slashes. These are what are referred to as single line comments. In this lecture, we're going to learn about multi-line comments. Because right now with these comments, right, like if I have this one, got food at 7-Eleven, and then I want to share some other piece of information, if I hit enter or return, I start a new line and I'm no longer part of this, you know, green comment, right? Like this right here is not part of this, and now you can see that's why we have an error. Like I'd have to do another one here to like share some more information, right? And for every new line that I want to do, I just have to do that. So if you want to, there's a really slick way to do multi-line comments, right? Where you don't have to keep typing these slashes over and over. And it's pretty simple. All you do is you do a slash and then a star, Let me give us some more space here. And then you do a star and a slash. And now everything between here and here is a comment. So I can start typing like my life story. I was born in a log cabin. That's not true at all. Then I was raised by bears. That's not also true. I learned to hunt with wolves. What am I, Mowgli from the Jungle Book? I don't know. But you can see how all these lines here, I can hit enter as much as I want. I could just keep going forever. These are all a comment. Each new line that I do, it's a comment. It's not considered code. I can type over here. I can type here as well if I want to. Typically, when you do these multi-line comments, you kind of keep these on their own line. But totally style thing, up to you, whatever it is that you want to do. But you can see how these are like a multi-line thing. Small note that I wanted to share is that if you're ever working on something and you have some code that you want to like get rid of just temporarily, you can always just put a comment in front of the code. You can see now this, wallet -5 never happened, so we actually end up with $100 rather than 95. But then I delete those comments. Right now, this is completely valid code back here. If you want to get rid of a big chunk of code, you just do /*. Then I'll do */ here at the end. Now all that code's not working, and I can, if I want to change that, just go put that back. So you may be asking, well, why would you want to comment out some code? Well, if you want to test something new, or you broke something and you just want to, hide some code for a second, that can be a pretty good reason to go comment out your code. And like I said, don't feel like you need to, but there's situations where it might make sense. Now I want to do one last thing here that will be kind of interesting, and that's what I want to show you a iOS project in Xcode and just show you how many comments there are when you start an app. So let's exit out of the playground and then open up Xcode. I'm gonna make sure it's Xcode beta, and let's just do create a new Xcode project. So I'll click on that. I'm gonna go under iOS application, click on single view application. For the name, I'm just gonna call this one junk. We'll delete it by the end of the lecture. And we just want to make sure we have Swift selected. All this other stuff, just don't worry about it. You can keep it however it is. But then we hit next. I'll put this on the desktop, just hit create. So essentially what this is doing right now, this is the way to start a new iPhone app that you can work on, do some stuff. And when you create a new app, Apple will actually give you some code to start off with. And so if we click on this app delegate and this view controller, there's some code that we can see. So something that's pretty neat is you should immediately notice from this, like, whoa, there's a lot of green in here. There's lots of comments. So when Apple starts you off with a project, they will give you lots of code and kind of explain what's going on at each different point here with these comments. So with this thing, app delegate, override point for customization after application launch. So this is saying, hey, when your app opens for the first time, this is where you can write some code to do any last minute things that you want to before the user starts using it. And then, this is something about when your app is going to go into the background, whatever, right? Like if we click on this thing called viewController.Swift, again, we can see some information. At the top of every chunk of code, Apple will automatically generate this thing where they say, this file is viewController.Swift. The name of this project is junk. It was created by Nick Walter on this date. Copyright 2016 Joe Mama. Now, that's pretty funny. I guess that's what I had in there as like the name of this, my quote unquote company or whatever. But so anyways, I just want you to know that like comments are used a lot of places. So now you know what those are. I've always thought it's weird when Apple does these big things at the top of the code. I would have thought maybe they just would have done the / like this, and then */ so that way they wouldn't have to, have all these things, right? They could have just deleted all this. Could have looked like this, but totally up to them. That's their style thing. And you don't even need these things for your code to work. Like we can completely delete this. It has no impact on our project. There's nothing magical about those comments at the top. Because remember, when your code is running, Swift will not run if there's a comment. Whether it's single or multi-line, it just skips over that stuff, right? Like it just says, I'm going to move over there. So we can go ahead, X out of this. I'm actually going to go ahead and delete that app. But I just wanted to show you comments are used in a lot of different places, and now you know what they are. So you shouldn't be as code illiterate as you were before. So now that you know what comments are, I'm going to start using them inside of our playground to kind of leave a little title at the top to say what it is that we're talking about in each specific lecture. So for this one, we're learning about print, but isn't that cool? That's a nice kind of application of comments. Hopefully you kind of see, oh, this is cool, right? Like this is a way to leave notes right on top of your code. Kind of awesome stuff. But enough of that. Let's talk about print. Now, print is a way for you to send some information in your code to the console. You may be wondering, what information? What the freak is the console? And I'll be honest, when we're working with a playground, there's not a huge need for Swift. Like there's not, it doesn't really make a lot of sense, but there's a ton of other situations where it does. So I want to at least show you how to use print, and then I'll show you where it really kind of makes sense. So to print something, and I think the word print is very misleading. At least when I think of print, I think about actually printing something on physical paper. That's not what we're talking about here. Basically, when you print something, you send some text to something called the console, where you can see some information about your app or program, whatever it is that you're running. So to do print, to make a print statement is what they're called, just type print. Then we're going to do a left parentheses, and then we need to put some sort of value inside of here. So that can be really almost anything. We can put booleans in there, strings, ints, whatever it is that you want. Generally, people put strings in there, but so let's just do one here where we say, whoa, got some stuff breaking. Hello world, okay. So we have that quote in there, or that string in there, and let's do the end parentheses. And you'll notice this little thing down here in the bottom, if you hit this little arrow so that it pops up, this is your console inside of the playground. And so if you print things, they will show up down here. Every time you print something, it shows up on a different line. So I'm going to do the emoji version of hello world. Let's get the hand waving. That kind of symbolizes hello. And then we want the world. Nice. Okay, so we'll put that in there. So now we can see we have hello world and emoji hello world. Kind of cool, right? So we can print these things and see them down here at the console. And again, you're like, well, why would I need that? I can usually see stuff inside of here. Well, there's certain situations where when you're not working in the playground, this really comes in handy. But let me just keep teaching a few more things and I'll show you those places. So you can print more than just strings. Let's say we have some sort of variable like age, right? Let's also do the weight one. All right, so 191 point something. I've lost like a pound since our last lecture, maybe. I don't know. But you can print either of these things if you want to. So you could do like print age, and you can see that it'll just print out 28 there. We can change that to weight. We can handle doubles. No problem. You may think, oh, okay, can I do both of them? Like if I want to do age plus weight, add those things together. Well, remember that issue about if you're going to add ints and a double, you got to change one to like a double or both to ints. So I'm going to put maybe that around there. But basically, you can put almost anything into print and it will show like the text version of it down here. So you can see 191 point whatever plus 28 equals 219 point whatever. So there's a lot of different things that we can print and they show up inside this console. So you may be asking, all right, I understand that, but like if I wanted to know what these things two were added together, I'd just get rid of this print stuff, and in the playground, I'd be able to see this over here. Well, that's true, and for the playground, I think that's probably the smartest thing to do, but there's certain situations where you can't. So remember when we just opened up that iOS app, we were working on stuff? There's no playground there. Like when you write code, in order to test your code, you have to hit the run button, and you don't see like all this output on the side of what happens with your code. Like you just have an app that shows up and you can like click on the app, but you don't see some of this information. So if you ever want to check what some values are or something, you can use print, and then in Xcode, there's a little console down there where you can see stuff. An even more practical example, go ahead and open up a browser. I'm going to do Safari here. And just go to Google first, and we are going to search for, IBM has this tool to allow you to write Swift code on the browser, which is pretty excellent. So come on, Google. There we go. So search IBM Swift Sandbox, okay? IBM Swift Sandbox. So you should get some link like this, swiftlang.ng.bluemix, okay? So go ahead and click on this, and you can see this is basically a place that you can type some Swift code. And their first example is this print hello world. So you'll notice as we type some code here, like I'm going to say let A be equal to 5 and let B be equal to 16. And then I want to know, what is A times B? As we're typing this stuff, we see no information out on the right. Like we could just type forever and nothing will change. With this Swift tool here, if we're going to run this or see what happens, we can hit this play button and then it will run this code. So as it does that, looks like we have an issue here. Warning, result of operator star is unused. Oh, because it's saying, hey, you didn't put this into like a variable or anything. You didn't use it. So just a warning, but you can see we have hello world here on the other side. I'm going to get rid of this for a second just so we don't see that warning, but we hit run, we can see hello world, but we don't see any of the information for this. And again, you saw as I did A times B, I get that warning saying, hey, you multiply these two things, but you never show it or anything like that. So the way to fix this, if we want to know what this is, we can do print, put a little parentheses around that with the print statement. And now when we run this, we should get hello world, and then 5 times 16 apparently is 80. Okay, so that's kind of the application of, this is the console here on the right, and it makes a lot of sense. You write some code and you can see it over here. So when you're running a Swift in a non-Xcode environment, like on Linux or Windows in here in the IBM browser, like this print will really come in handy. And like I said, again, when you're working on iOS apps, you will see that as well. So hopefully that wasn't too much information. Print is also kind of similar to comments in that I get students asking me, well, when should I be using print? I feel like I'm not printing enough. Well, don't worry about it. I do not use print unless you have a need for it, right? Like if you're working in that IBM, cloud situation, you're going to be using print a lot. If you're on Linux, you're going to be using print a lot. But, if we're here in the playground and you can get all the information that you need on the right here, don't really worry about it. It's not that big of a deal. So just take a break. Don't worry about it. But at least now you know what comments and print are and how to use them. And if you see them in code, you won't be completely confused. So hopefully you had a nice mental break there. Like I said, comments and print aren't that too hard to understand. This was a shorter section, but we're going to ramp things up. We're going to learn some awesome fun stuff in the next section. Let's dive into it. This section is about switches. Yeah, switches with my witches. We're going to make a brew that is cool. Okay, enough rapping by me. Switches. I like to explain them as a very close cousin to the if statement, and I'll show you that in the lectures. Let's go ahead and dive in. It's time to learn more about Swift. So let's kick things off by talking about switches. Now, isn't this cool? Because now that we've learned about comments and stuff, I can kind of leave the title of whatever it is that we're going to talk about up here at the top. I think that's just money. It's awesome, and it's a really good use case for comments. But enough about comments, let's get into switches. Now, as I said earlier, switches are a close cousins to if statements. In fact, I tried to think through this. I think any place that you use a switch, you could probably also use if statements to accomplish the same goal. But as I will show you, there are situations where a switch statement makes much, much more sense. So in a nutshell, a switch basically allows you to take some value from like a constant or a variable and say, if the value is this, then do this. If it's this thing, it's that. And you hear how I'm talking, it kind of sounds like if statements already. But I think just by showing you an example where I first create it in an if statement, and then I instead use switches, you'll understand, oh, okay, I understand why this is a much better way to do things. So the situation that I'm going to present you is, let's say we are a teacher, maybe like high school English or something like that, right? And we just gave out an assignment. We wanted kids to write papers, and we had to give all the students grades. And so, we might give them an A, a B, C, D, an F, whatever. And as we give them a grade, we want to give them some feedback. So if they get an A, we want to say, great job. If we give them an F, it's like, whoa, you need to do some work, kind of a thing. So let's use Swift and make a little program that will be able to provide that response for us. Okay, so let's dive into the code. Let's make a constant just called grade. All right, and I'm going to set this equal to, let's start it off with an A. Let's do best case scenario. And then let's use some if statements to make a response. So I'll say if grade is equal to A, and I got to do that double equal sign, remember, if you're going to compare two things. Curly bracket. And so if the student gets an A on their paper, I want to say, and let's just use a print here. This will be a nice way to kind of use what we learned from last section. I'll say print I'm going to print out a little statement here. I'll just say, you did a great job. Okay, so now if they got a B, well, we essentially want to do the same amount of code, right? Like we're going to come down here, we'll replace this as a B, and then we'll change the message to say something like, good job. Okay, no exclamation point at the end of this one because it's like, yeah, good job, you got a B, that was great. Then if it's a C, essentially the same code again, but we just got to switch this to a C. And instead, this time we'll just say solid. All right. If they get a D, we're going to say, not your best. And then if they get an F, and why is there no E? Did you ever wonder that in school? Like it goes A, B, C, D, and then F? What happened to E? I'd love to get an E sometime. But if they get an F, we're just going to say this one's soul crushing. Yikes. ... So these are our responses for the students. So you can see as if it's an A, we get this message, you did a great job. But if I change this to C, then we get the message solid. Okay. If I change that to a B, then we'll get the message good job. If I change it to an F, ooh, we get that yikes ... Okay. So this is completely valid code. It's legit. This is using if statements, right? But I'm going to show you how to accomplish this same result, but using a switch statement, and you're going to kind of realize, oh, okay, this is how this can be a lot easier. So down below this, we're going to create our switch. To make a switch, all you do is type switch, and it's lowercase, space, and then you have to give it some sort of variable or constant, some sort of value that's saying, hey, depending on what this is, we're going to make a different decision. So for us, depending on what the grade is, we're going to have different responses. So I'm going to do switch space grade. It's just the name of that constant up there. And then I'm going to do curly brackets. And then inside of the switch statements, we have to give it some cases saying, in the case that it's A, we want to print this. If in the case of B, we will print this. If in the case of this, we will print C, yada, yada, yada. We can just move on from there. So I'm going to type case, and then I just do whatever, saying if the case is A, meaning if the grade is A, all right? I just put that string in there. Then I do a colon, and then I do a new line, and on this new line, you can see it's kind of tabbed over here. This is where you type the code that you want to have happen. So for us, we just want this line up there. You did a great job. We'll go ahead and paste that, all right? And then now we can do another case. You kind of have to delete this to get back here so that the case is on the very left. We'll say case, and let's do B. All right, so if they get a B, then we will just print out good job. All right, and we're just going to do these for the rest of the grade. So I'm going to kind of just copy one of these, paste it out a few times. Yep, now we have one for C, D, and finally F. Now I just need to get the messages from there. So we have solid for C. Let's put that in there. Let's get the D message. We'll put that in. Then we have an F. Copy that and put that in here. Okay, now this still isn't complete code. You'll see that we're still getting an error here. And what we need to do is just type default like this. And for right now, we're just going to print nothing. Okay, and in the next lecture, I'm going to dive into what default does. But I want you to see, now we get yikes 2 times because this switch right here does the exact same stuff that all these if statements do. So watch this. If I change this to an A, the code will come down here. It passes this if statement, so it says you did a great job. But when it comes to the case, this is what happens. It says, okay, I'm going to do a switch on this grade, and it says, what is grade equal to? And it says, oh, well, it's equal to A. So here's says, oh, if it is A, if the case is if the case that grade is A, then we're going to run the code right here, right? If it's B, we'll run this. If it's C, right? And so it finds that, runs that code, and then it just keeps moving. So let's change this to something like a D, all right? It would come to this switch that said, okay, grade is not equal to A, it's not equal to B, it's not equal to C. Oh, it is equal to D. I'll go ahead and print something out here, okay? So I just want you to notice these 2 things do the exact same job, but the big difference here is that this just looks so much cleaner, right? Can you kind of tell that from the switch? Like it's very easy to understand what's going on here. It's saying, if the grade's an A, a B, a C, a D, then you want to do these things. Whereas up here with the if, it's like we keep have to saying if grades equal to A, and if grades equal to B, and grades equal to C and D. Like, it's so repetitive, where with this we're just saying, hey, if it's A, B, C, like do these different things. So hopefully you kind of can see from this, this is where things make a lot more sense. You can have more than one line of code. Like I can print, two different things here if I want. I'll just say hello. Let's go ahead and change this back to an A, make sure that runs. Yep, you can see that. So you might be wondering, okay, if the case is A, what code gets run? Well, it's any code until another case shows up. So this could be like, 5-10 lines if you wanted to, but we just need the one line for each of these. So there is your quick dive into switches. We're going to obviously cover more details through the rest of this section. And the next lecture is going to be all about this little default thing. I'll tell you about that. So as promised, I'm going to dive into this little thing called default down here. So now that I kind of illustrated the difference between if and switches, I'm going to go ahead and delete this if statement up here. Well, all of these if statements. So now we just got this grade one. So let's talk about default. So default is there because when you do a switch on something, for example, this string constant, it's trying to figure out, okay, depending on what this is, I need to run, certain code. So if it's A, well, I need to print this. If it's B, I need to print this, C, this, D, this, F, this. But then default, you might be wondering, what's the default? Well, when you do a switch, you have to make sure that you cover every single possibility that could arise with that value. So for example, a string can be anything, right? Like we could have a string be A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P. It could be any letter. It could be words. It can be emoji, right? Like, remember how I talked about there's like infinite possibilities for what a string could be? Well, this switch statement, it's a rule in Swift that it has to run some piece of code somewhere. Like, it has to decide, okay, this is going to be, what am I going to run? Well, if it's A, I'll run this. If it's B, this, C, this, D, kind of goes through. But this default just says if it's none of the above, if it's none of the above cases, well then just as by a default, run this code, right? So it'll say nothing. So watch what happens when I set this equal to E. Remember how I said there's no E letter grade? Well, it now prints out nothing. If I change this to just some random gibberish, it covers this inside of there. Like if I make it an empty string just by 2 quote marks, like it goes to nothing. So it's a rule with switches that they have to cover every situation. Now, something that's sort of interesting, I'm going to make a new switch here, and I'm going to have it be a switch for a Boolean. So I'm going to make a Boolean constant, and I'm going to call it sunny. Remember, like whether it's sunny outside or not, and I'll say this is true. Now, if we're going to make a switch statement for this constant called sunny, right? So I say switch sunny, right? Do my parentheses here. There are only 2 situations that this could be because Booleans are either true or false, right? So I can say in here, case true, colon, or I can say case false, colon. And, inside of here, maybe I'll just print it's sunny, all right? And then in this one, I will print, oh, come on. Got to do my string in here. It's not sunny. Okay. So very simple switch here, right? It just says, okay, if sunny is true, then I want you to run this line of code. If it's false, then I run this. But you'll notice we don't get any errors from Xcode here because with a Boolean, there's only 2 possible situations, right? It's either true or false, and we covered all those situations. So hypothetically, let's say with this switch thing, if we were able to write a case for every single possible string in the entire world, well, then we wouldn't need a default. But because there's almost infinite and we would never spend the time to go type those out, we have to have a default that's kind of a catch-all that says, well, if it's none of the above, then I want you to do this line of code. And down here with this, it can say, because this is a Boolean, it's either true or it's false. This covers all situations, all right? And I also would like to, you can see how we did a switch statement on a Boolean. You can do it on any type of value. You can do them on ints if you would like. So For example, I'm going to change this, like the grade, to an int now. You know, I could say like 1 here, 2, 3, 4, 5, and we'll keep that as a default. But I mean, this is completely valid code, right? If I say it's 1, it does that stuff. If I say that it's 3, we'll come down and say solid. So yeah, switches aren't just for strings. They're not just for Booleans. They're for any kind of type, and you just have to provide some cases for it. So there you have it. That's default. Let's do an exercise. Make sure you got this, and then we'll keep trucking. In this lecture, I'm going to teach you about multiple matching. This is something with switch statements where we can kind of combine our efforts to say, hey, if it's any one of these things, then go ahead and run this chunk of code. Just, you can kind of combine powers there. So I think Apple in their documentation had a really great example, so I'm just going to straight steal it because I think it's such a great way to illustrate this. So they said if you're trying to determine whether a letter is a constant or a vowel, here's how you could probably do that with a switch. So they had created a constant, called it letter, and right now let's just set it equal to like A, all right? Then let's use a switch statement to say, you know, let's figure out if it's a vowel or a constant. So what are the vowels in English? A, E, I, O, U, right? And sometimes Y. We could probably debate that one. So we're going to say switch letter, do our little curly bracket thing, and we'll say case. If it's A, you know, then we are going to print vowel, just like that. All right, and we'll have to have a default down here eventually. Default, and this one's just going to say lowercase print constant. Now we can find if it's a vowel or a constant. Or is it consonant or vowel? No, constant? I have to go look this up. Give me a second. Oh, good heavens. I had to go Google vowel or consonant. It's consonant. And so I apologize for my stupidity. Let's move forward. So, you know, here we have, got rid of my curly bracket. If it's A, we're going to say that's a vowel. Then we have to update a few other ones down here. So we'll say, you know, A, E, that's another choice. All right, so we'll copy paste. Let's just do this a few times to get all the other ones. A, E, I, O, U, and we're going to leave out Y. Okay, so it could be one of these 5 things. So this code is fine, right? Like we can, you know, if we change this to an E, still says that it's a vowel, but if we change it to something like a B, it says, oh, this is a consonant. Should update there. Yeah, but a much simpler way to do this, and the important thing to note here is that we're doing the exact same line of code, whether it's an A or an E or an I or an O or U, we're just printing vowel, like we're doing the exact same thing. So if we want to just group this all together and save a bunch of space here and a bunch of messiness, to be honest, we will delete all of this, and then just on this case line, we'll say, do our string A, but then we're going to do a comma, and we're going to add another letter here, A, E. We're going to keep this up. A, E, I, O, U, like that. And look at this. This completely works. If I type A into here, this code gets run. If I type E, this code also gets run. If I change it to a U, it also gets run. So basically all this is, this multiple matching says you can put multiple cases on one line if you want the exact same code to be run inside of there. So you can see this just looks so much cleaner. It's much more condensed, and it's like, oh, okay, if it's A, E, I, or U, that must mean it's a vowel. If not, then it's a consonant. Bada bing, bada boom. There you go. We all know how to spell consonant now and know that it's not consonant. I think I've been programming too much. I've forgotten English. Anyways, let's go do an example and then we'll move forward. In this last lecture of this section, I want to talk about interval matching. So it's a really cool way to use switch statements to say, hey, if a number is between here and here, run this code. If it's between here and here, do this other code, okay? So I think a really good example that we could use here to kind of learn about this interval thing is go back to an age thing where we say, you know, if you're this age, you're a minor, you're adult, like whatever, we can kind of do some cool stuff there. So let's go ahead and create a constant. We'll call it age, and I'm going to set this equal to Again, my age 27. And then I'm going to do a switch statement, okay? So I'm going to do a switch on age, do my little curly brackets. I'll make sure I have a default down here, and right now I'll just have it say hello. But for the other things, I want to say, hey, if the person is between 0 and 5, I have no idea if that's like toddler age, but we want to say that this person is a toddler. So this is pretty neat. I mean, we could go case 1, 2, 3, 4, 5, or we could just do this thing where we say 1 dot 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 5 colon. Now, if it's anywhere between 1 and 5, this will, we can say, we're not going to do a print. Let's just use strings here. We have the simulator. We'll just say toddler, okay? And I'm probably spelling that wrong. You can see how I had the spelling errors, the consonants, but we'll be okay with that. Now let's say, if they are age 6 to age 17, we could just say they are a kid, all right? And then from case 18 to 65, you are an adult. And then case 66 to 150, you're an old dude. Rock on. Shout out to all the old peeps. So I'm going to go ahead and just kind of organize this. I forgot to do the colons at the back of these. That's probably why they didn't move automatically left. But we do this, and look what happens. So I put in 27. You can see that I'm an adult. What happens if I was age 11? It would say that I'm a kid. If I change this to age 2, it'll say I'm a toddler. At least it should. Come on. And if I change this to like 90, should say I'm an old dude. Rock on. So you can kind of see with this interval matching thing, you can kind of use numbers to say, hey, if it's between here and here, do the following. If it's between here and here, do the following. Again, just one other way to use switches. So there you have it. We're all done here. I'm going to go wrap things up in the outro, but of course you got to do one more exercise. Well, congratulations on finishing this section about switches. Like I said, switches, if statements, they are very closely related. I still believe there's no situation where a case could not be replaced or a switch could not be replaced by if statements. But like you saw with like the grading example, there's a lot of situations where the switch just makes more sense. It looks a lot cleaner. So you'll find appropriate ways to use them in your code. And if you're looking at other people's code, you'll recognize it and hopefully see why they chose that. So we're going to keep moving on with Swift. Remember that print and comment section? That was pretty easy. We're kind of warming things up here. In our next lecture, we're diving into arrays. Things are going to heat up one more notch, but I believe in you. Keep trucking. You're learning Swift. This section is all about arrays, and arrays are a really fundamental programming concept. You see them in all types of programming languages and almost any piece of software. There's probably an array somewhere in there. The best way to think about arrays is they are lists of things, particularly an ordered list of things. So they're inside of apps, websites, you name it. Arrays are being used. So I'm going to walk you through these start to finish. By the end, you'll understand arrays and understand why they're important. Let's dive into it. I think a really great way to think about arrays is as if it was a list, and a list with some sort of order to it. So if you think about maybe you have some sort of mental list of your top 10 favorite movies, right? Like for me, probably Sandlot at number 1, Emperor's New Groove number 2, and then something from the Batman trilogy in number 3, right? Like whatever it is, I've got some sort of list of my favorite movies, like this is 1, this is 2. That's a good way to think about arrays. They're lists with some sort of order to them. So let's go ahead and dive into an example, and I think you'll kind of see how they work. And just know that arrays are used anywhere. Anytime in software there's some list of something, it's probably backed by some sort of array. Like if you think about in the iPod, music player app, as you're scrolling through songs, that's just a big array of songs. It's a big list of all the songs in like alphabetical order. When you're on like your Facebook timeline, like they have to order their posts somehow from the ones that are like either the most recent, or they're saying these are the ones that are top for you. Like, it's a list of these posts, and I don't know what's on the back end of Facebook, but it's probably some sort of array. So just think, anytime you see a list of something in software, there's probably an array behind it. So anyways, let's dive into an example and get to know arrays a little bit better. So I'm going to come here to the playground, and I'm going to go through the example of making that list of movies. Okay, so I'm going to say var movies, and it's important to know arrays are just another type, just like string, int, double, boolean, right? All those things. But you'll notice that it's kind of like a type within a type, but we'll get to that. Don't worry about it. So to make an array, I'm going to say var movies is equal to, then I'm going to do the square brackets. These are different from parentheses or curly ones, square brackets. And then inside of here, I'm going to list some of my favorite movies. So like I said, number one for me is Sandlot. Okay, so that's the first item inside of my array or my list. Like I said, kind of good way to relate to it. To add another item, I'm going to do a comma. Then I'm going to do some other, another string inside of here. Emperor's, is that how you spell emperor? Emperor's New Groove. That might be incorrect. And then we're going to do another comma. Okay, and then come on here and I'll just say Batman. So here I put three different strings inside of this array, and this is a complete array right here. You can use this. This is totally valid. So the important thing to note is with arrays, they can have anything inside of them. You can have an array of strings, you can have an array of ints, doubles, booleans, whatever you want, but just know that arrays have to have all of the same type inside of them. We couldn't have like a string in here, and then an int and a boolean. Like, they all have to be strings, or they all have to be doubles, they all have to be booleans, like whatever. So let's go ahead and just keep moving with some other example. Let's make an array of some lucky numbers. So this one I'll make it a constant. I'm going to say let lucky numbers be equal to, and I do these square brackets again. This kind of denotes that it's a array. And then I'm going to just put some ints inside of here. So 8's a lucky number, 14, and 27. Okay, so let's say these are my three lucky numbers. Now I have an array with these three ints inside of them. Should we do an array with booleans? I can't think of a great example for this. So maybe let's not. Well, I'll do one just for the heck of it. Let's make this one a variable. I'll just call it all my bools and say this is equal to an array, and I can just put like true, 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 false, true, false. I mean, I don't know. You can put whatever you want inside of these arrays. But you can see there's all these different types that we can put in there. And so if you want to know, remember how we can do that type annotation with stuff like if I have var age, I can specify that this is going to be an int and set that equal to something, right? Well, we can do the same thing with arrays. And to do that, we'll do our colon just like we always do, but then you do the square brackets to signify that it's an array. But then you have to specify what type of array it is. So for this one, it's a string array, so we have to type string in here. For this one, we would do the square brackets and then type int. Do you kind of see how we're doing this? So to specify the type of array, you have to then specify what's inside the array. So you kind of have to, do two things for that type. But can you guess what we would put here for an array of booleans? We'd go colon, square brackets, bool. Just like that, saying that this is an array of booleans. All right, so there you have it. There's our intro into this. Obviously, this whole lecture, we're going to dive into these. There's so much to know about arrays, and I think the more and more you work with them, you'll understand, yeah, I see these are a useful thing for us, and I could use this when I was making software. So let's go ahead, do an example, and then keep moving. In this lecture, we're going to dive a little bit deeper into arrays with learning how to append things onto them and also figure out their count. But first, I have to fix my terrible spelling mistakes. Emperor has an E here that I left out. I Googled this in between filming the last one and this one. And also, I had Emperor's New Grove. No, it's Groove. Come on, Nick, you're better than this. Well, probably not. I suck at spelling, but there's an update to that. So first, let me talk about appending things. So we have our list of arrays here. Let me get rid of this age thing, right? So we have some favorite movies, lucky numbers, some Booleans. Honestly, this Boolean example is a little bit weird and I don't want to like confuse stuff. So let's just get rid of that. So I want to talk about how after you create an array, you can add things onto it. So you can see this one here, var movies. It's a array of strings. We don't have to have this thing here, but it just kind of specifies it is an array of strings. I'm going to go ahead and get rid of that for both of these just so that it's a little bit cleaner. Because when you are making arrays, you don't have to go all crazy and do that type annotation. Just go ahead, create the array, and Swift will know, oh, this should be an array of strings. But anyways, let's say we want to add something onto our movies. I've decided what my fourth favorite movie is. So I'm going to go movies.append, and you'll see as I start typing append, there's this option to add a new element. So the technical term for each of the items inside of an array is called an element. For some reason, I love to call them items, but I feel like I should probably tell you the official name of them is element. But anyways, so you movies.append, or whatever the name of your array is, and then you can add a new item into there. So for example, with here, I would have to add another string. If I try and add a number like this, like, it's not going to work. But if I do add a string, like, this is totally fine. This is completely valid code. So let me go ahead and add a fourth movie here. Maybe Ferris Bueller's Day Off. The odds of me spelling Ferris Bueller's Day Off is pretty rare, so probably not going to happen. So I'm going to just do the acronym for it, FBDAO, Ferris Bueller's Day Off. And so anyways, when I do this, let's go ahead and look at our playground here. I'm going to expand it a little bit bigger, make this right side come out a bit. So you can see when I created this array of movies, it had three things inside of there: Sandlot, Emperor's New Groove, and Batman. Then when I do this append, it adds Ferris Bueller's Day Off to the end of that array. Now there's four things inside of there, right? So I was able to say, these are all my movies, and now I want to add one more onto the end of it. And you can just keep adding and adding if you like to. Like, let's add one more onto here. So we'll do this dot append. Maybe another great one's, I can spell this one, Back to the Future. Okay. So now you can see if I pull this out even more, now there's Back to the Future. So we can add things onto the array if we'd like to. And if this is ever getting too big, you can always just print out the array to see what's inside of there. Like if I just say print movies, which is the name of my array, we should down here get all the movies. Well, the playground's not cooperating. There we go. Sandlot, Emperor's New Groove, Batman, Ferris Bueller's Day Off, Back to the Future. So you can see how it's growing. So something important to note here is, okay, look, we have this constant called lucky numbers. It's got 3 in there. Let's say I acquire a new lucky number. Wow, the number 9 is just a very special number to me now. I want to add it to my lucky numbers list. So I can type lucky numbers, and then I do dot append like this. And let's say I try and add the number 9. Well, we're going to have an issue. Xcode screams at us. The problem is, remember, we learned this in the very first section, constants cannot be changed once they are created. So because this is a constant, this will never change. Like this array here will always be these 3 ints. It won't ever change the order of them. It won't change what can be added in at the end. It can't remove any. Like that is it. We can't make any changes. Now, if we change this to a var like that, so now that's a variable, well, then this is totally valid code and I can add my extra number here. But as long as it's a constant, we cannot do that. So one other thing that I want to show you here with arrays, if you want to, you can figure out the count of an array. So with these movies, right after I've created them, let's say, I passed in a ton of movies and I don't know exactly how many I added. It's kind of easy to count since there's just 3 here. But if I didn't know that, I could just say movies dot count. And this is kind of interesting. You'll notice as sometimes you're typing things, there'll be some information to the left of this, and will tell you what kind of type you're getting out of this. So we're getting an int from this count thing, which, the count is an int. Those are whole numbers, right? So this will tell us exactly how many movies are in there. So you can see that it says 3. And if we just kind of copy this and put one after we add Back to the Future, you can see now it says that there's 4 movies. Now it says that there's 5 movies, right? So it just kind of keeps updating that. And it's important to note you can't change the count of this movies array by saying, oh, you know what? Movies.count is now equal to 2. Like, you can't do that. We're going to get in there here. You can only figure out, like, you can't write information to count. You can only read information from count. So you can always ask an array how many things are in it. You can't tell it specifically. You have these many things. It just knows how many things there are by checking what's inside of it. So you can just kind of ask if you want to. But there you have it. You know how to add things onto an array now. You also know how to figure out to the count, but we're not done there. Let's keep moving into arrays. In this lecture, I'm going to cover how we can get specific items out of the array and also how we can update items. So let's go ahead and clear out some things here. We really don't need this lucky numbers example. I think you understand that you can have either strings or ints, doubles, whatever kind of type it is you want in an array. So let's just work with this movie one. Okay, so we've reduced it now to just the movies, and let's talk about how we can get a specific movie out of this array, because what use is it that you have a list of things but you can't access the list or get things out of it. So for example, if you wanted to get the very first thing out of this array of movies, which would be the Sandlot, it's pretty simple. You just type the name of the array, movies dot first, and it will give you back whatever the first thing is in there. So you could say, like, let's make a new constant called my fave movie, and we're going to set this equal to whatever is first in the movie list, right? Like, that's totally valid. If we wanted to get the last movie out of the array, let's change this now to something like worst of the best, right? If it's the very last position on my top 10 list, that means it's the worst of the best. So all we do is change this to last. So we know how to get the first item out of an array, and the last item out of the array. But what happens when there's lots of items in the array? Like, for example, how do we get to Emperor's New Groove, right? Like, there's no middle or second or third. Like, how do we get to that? Well, let me show you. So if you want to get to any specific item in the array, you just have to give an index or what number position in the array that you want to get to. So, right, like there's 3 items in this array: Sandlot, Emperor's New Groove, Batman. You would think if we were to number these, it would be 1, 2, 3. But with arrays, and this is just not in Swift, this is in lots of other programming languages, arrays use zero-based counting, which means the very first item in the array is the 0 number. It's not, you don't go 1, 2, 3. In this case, you'd go 0, 1, 2, which I know is bizarre. At least for me it was when I first learned about arrays. I'm like, why are we counting from 0? Like, this makes no sense to me, but it's a big tradition in programming. Lots of people use it. If I could, I would suggest that it would go the other way, but I'm not involved in the creation of Swift at all. I'm just here to teach you how to use it, and it won't seem that bad once you get used to it. Now, you're probably going to make lots of mistakes. I can't tell you how many times I've worked with arrays. Still, sometimes, like, I'll ask for the one item in an array thinking it's the first, but it's actually going to give me the one that's in the second position. So anyways, let's just mess with it and you'll kind of get how things work. So we're just going to type movies, okay? And then we're going to do, right after the name of the array, square brackets, and then inside of here, put the index of what you want to get. So if you want to get the very first item in the array, you're going to give it an index of 0. So we pass 0 in here, and we get an Xcode crash. How timely. Let's open this back up. But so if we ask it for the one at index of 0, it will pass us back Sandlot. Do you see that out on the right? So whenever you have an array, if you ask it for the index of 0, that's the exact same thing as asking for that array dot first. They're one and the same here. So what happens if we want to get the next item in here? Well, if we pass a 1 in here, it'll give us Emperor's New Groove. If we pass a 2 in there, it'll get us Batman. So even though Batman's the third item in the array, if you're doing it on like array terms, you start counting 0, 1, 2. That's how we get Batman. So let me just add a few more movies to make sure we're understanding this. I'm going to add Ferris Bueller's Day Off. Okay. And I can't even remember what the other movie is that we were working with. So I'm just going to go add a random one. I'm going to add ants. That is definitely not in my top 10, but it's just there kind of for example's sake. So what would happen if we wanted to get Ferris Bueller's Day Off? Well, if we start counting 0, 1, 2, 3, we would put a number 3 in here. What do we get? Ferris Bueller's Day Off. And if we want to get the last one, ants, we'd put a number 4. Even though it's technically like the 5th one in there, there's 5 items, it's the 5th. We put the number 4 to get the last one. So you might be wondering, well, how could we get the last one? Well, we can always do the classic thing where we just say, you know, movies.last, which will get us the very last thing in there. But if you wanted to work this out on your own, what you can do is just say movies.count -1, and this will always be the last item in the array. Okay, so look what happens even if we delete one here, because right now if we run this, the count is equal to 5. Just to prove that to you, let's do movies.count. Okay, you'll see we get the number 5. There we go. So when we say movies and we're giving an index of 5 - 1, which is 4, that's the very last item in there. Look what happens when we delete ants. Okay, so now there's only 4 movies in there. Well, the count of it is 4. It still gives us the very last one. So that's how you can kind of get to them. So yeah, working with, if you want to get a specific item in an array, you just do these square brackets right after the name and you pass some index into there. It'll pull that thing out. Now you can use this same thing to update a value or change a value in an array. So for example, we look at this array, we have Sandlot, Emperor's New Groove, Batman, and Ferris Bueller's Day Off. Well, what if I want to change you know, my Batman selection? It's like, you know what? I think ants should go in the Batman selection. I can put in the number 2 here because 0, 1, 2. And then once you do that, and assuming Xcode won't crash on you, you'll say this is equal to, and then just put in a new value. So I'm going to put in ants, for example. All right. And now that we do that, I'm just going to type out movies so we can see what we get here in the right side. But essentially what we're saying is, okay, movies array, I want you to go to the 2 index, which is Batman. I want you to change that to ants, and look what happens. Right here we have Sandlot, Emperor's New Groove, Batman, Ferris Bueller's Day Off. We say change the 2 position, index of 2 to ants. Now it's Sandlot, Emperor's New Groove, ants, Ferris Bueller's Day Off. So we're starting to really learn things here with arrays. We know how to add things onto them. We know how to get to a specific item in the array, and we know how to change things. So a few more things that we've got to learn, but we're really diving in with arrays. I hope you're understanding. If you have any questions, please post them. I want to make sure they get answered and you don't get lost in all of this. I'm taking a deep dive into arrays, and I'm hoping that you're able to keep up with this. Let's keep trucking. This lecture is about inserting items into an array and also removing items from an array. So first, let's start with inserting. And the previous example that I had here, right, I had my array of 4 movies, and then I decided, you know what, I want to replace Batman with ants. That's fine, but when I do that, Batman is no longer part of the list, right? You can see there's the 4, and all of a sudden ants is here, but Batman's nowhere to be seen. Let's say maybe I want ants to go right in here in between Emperor's New Groove and Batman, but I want to keep Batman and Ferris Bueller's Day Off. So let me show you how to do that with something called insert. So we're going to delete this code, and instead what we're going to do is type the name of the array, which is movies. I'm going to do dot insert, all right? And with this little cool feature of insert, we can put a new item in, and so you just type the item, which for us is going to be a string. Let's do ants. And then I ask at, which is, it's really asking at what index position do you want to add this movie ants, or this string ants. So for us, we want to put it at not the 0, not the 1, but at the 2 position. So if we put the number 2 in here, look what happens. Let me spill this over so we can really see the whole array here. It will take ants and it goes, all right, 0, 1, 2. I'm going to put it right here. And now Batman and Ferris Bueller's Day Off move. So the insert is kind of like append, but the append will always put the new item at the end of the array. With insert, you can say, I want this to go at the very front, or I want it to go at this specific item. Like, look at this. If we do a 0 inside of here, you can see now ants is the top movie and everything just shifts down 1 space. And with arrays, they always keep their order. So when you're inserting something, if you put it in a position, it's not like the stuff before it or after it that order changes. No, it just kind of slides down one position, and then this is the new situation. So if you want to insert at a specific point rather than just append on to the end, this is how you do it. Now, the next thing that I want to talk about is how you remove things from an array. So let's say we put ants into here and we decided, you know what, that was a big mistake to put ants in the list. It shouldn't even, I put it in at number 1. It shouldn't even be number 1. I want it completely off my list. Well, the way to do that is pretty simple. We just type movies.remove, and there's all sorts of different options for remove. So there's remove at a certain position, just like this one. There's remove all, there's remove last, remove first. Like, there's really all sorts of situations, but we're going to look at this one first. Remove, and then we give it a specific position. So if we want to take out the very first movie, we put the 0 in there, and look what happens. I'm going to type movies down here just so you can see the output on the right. But we had our 4 movies. We inserted ants at the very front. Then we say remove whatever's at the very front. Now it's back to how it originally was. Well, let's say maybe instead of removing ants, we like ants at number 1, and we just want to get rid of Emperor's New Groove. Well, we count in this array 0, 1, 2. So we're going to change this to 2. We want to get rid of the 1 at 2. And all of a sudden, that goes away. So now it's Ants, Sandlot, Batman, Ferris Bueller's Day Off. Okay? Pretty simple. Now, it's important to note with these insert things, you got to be really careful in the removing thing that you're using correct indexes. So if I say remove, let's see how many are in here. 1, 2, 3, 4. But remember, if I was going to count these in array terms, it'd be 0, 1, 2, 3. Like if I say remove at 4, we're going to get a nasty little error here that says, well, it should say 0, 1, 2, 3, 4. Why is there? Oh, because we inserted the ants thing, and now there's 5. All right, let's delete this so we can kind of see. Just want to show an example here. So if there's only 4 things in there, asks for something at the 4th position, which there isn't, right? Because 0, 1, 2, 3, it gives an error. It says out of index, out of range, meaning the only options are 0, 1, 2, and 3, and you gave the number 4. This also goes for if I was just straight up trying to get something out of movies and I tried to pass in a number 4, again, we're going to get an error that says, whoa, this is index out of range. So in this case, it'd have to be the 0 or the 1 or the 2 or the 3. And I believe it also, if you give it a negative number, it's going to freak out. Like if I do -2, let's see what happens. Come on, Xcode. Yep, index out of range, no bueno. But +2, totally would work. Let's see, 0, 1, 2. That should be Batman. There's Batman. Okay, we are doing great. Just one more thing to cover, and we are done with arrays. Awesome work. So the last thing that we're going to talk about with arrays is this cool little thing called contains, which basically tells you whether something exists or does not exist inside of an array. So to use it, it's really simple. You just type the name of the array, which in this case is movies, and you just do .contains, and you see this gives us back a boolean of true or false saying whether something's in there or not. So let's ask it if the movie Spider-Man is in there, which actually probably would be in my top 10. I'm surprised I didn't add it. But you can see if I search for Spider-Man, I get back a false. It's like, oh, okay, this is not inside of the array. If I give it something like Ferris Bueller's Day Off, whoa, all of a sudden it says true. It says this is in the array. So this can be helpful when your arrays get really, really big and you're like struggling to know what's inside of there, right? And you're like maybe doing some sort of search thing, trying to find something. This .contains can be really helpful to tell you whether something is in there or not. And like I said, it gives you back a boolean saying it's either in there or it is not. So one more thing that I'd like to add here is a close cousin to contains is index of, which will actually tell you where in the array something is if you ask for it. So for example, we got Sandlot, Emperor's New Groove, Batman. Let's say I want to find out where Batman is. So I'm going to do .index and this one that has the of here. Okay. So I'm going to pass into here the name of what I'm looking for. And so I'll type like Batman, for instance, and it will give me back the number 2, which that is the index that Batman is at, 0, 1, 2. Like even if I delete Emperor's New Groove, so now this is updated, shows that it's at 1. Okay, so you can kind of see how using both contains and index together, you can find if something's in the array, and if it is, you can find out what specific position it's at. Now you might be asking, well, what happens if I search for something and don't give the exact name of it? Like if I do Batman with a lowercase b, right? Because the spelling has to be exactly right. Well, you get back this thing called nil. Now, later in the class, we're going to talk about this nil thing. It comes when we're working with optionals, but for now, just know that means that it couldn't find anything inside of the array. So hopefully you enjoyed learning about both contains and index. Let's roll to the exercise and then the outro. I hope you enjoyed learning about arrays. We dove really deeply into arrays there. We learned a lot of different things, but kind of to take a step back, what is an array? It's a list of things, and those list of things have a very specific order. So I hope you kind of saw how they fit into a lot of pieces of software. Like when you check your email and it's showing all the emails in your inbox starting at the most recent to some other one, like that's an array of emails in your inbox, and it will show those up. Again, if you're scrolling through tweets, like that's an array of tweets. In your music player app, you're scrolling through music, it's an array of music. Anytime you see a list somewhere in software, there's probably some array there backing all of that. So congratulations, but we still got tons to learn. Let's keep moving. Hey, check it out. We got this cool green screen here. You won't see it in this video, but in the next lecture, you're going to see where I'm going to do some cool floating head stuff. So got rid of that backdrop that looked like it was from a 90s grade school photo shoot. We're working with green screen now. But let's get to what this section is about. It is about for loops, and I love for loops. They're really, really cool, and they work well with what we just learned in arrays. So some pretty awesome stuff here. Basically, loops allow you to run through a certain chunk of code over and over and over again, and you can, control exactly how many times you want to do that, but ultimately loops are just a way to loop through a bunch of code. So let's go ahead and dive into it. You might be saying to yourself, Nick, what is this green screen? It's uglier than the other background. We like the old background. Oh yeah? Well, could the old background do this? Bring! Whoa! Now I'm this floating head in the bottom of your screen. Is that cool or what? All right, enough with the green screen. Let's get back to the for loop. So what is a for loop? It's something that allows you to run a certain chunk of code over and over again. And I think this is where, programming up to this point, it's been kind of standard, and it's like, yeah, we can tell the computer to do this, but we honestly could have done that on our own. For loops is where the computers and the humans split at the fork in the road. Like, computers can do insane amounts of work that humans could never do. I'm going to show it to you here with our very first for loop. So to make a for loop in Swift, what we're going to do is type for space, then we're going to do an underscore. That's hold shift while you're hitting the minus button. Then say in, and then we have to give it a range of numbers that we want to loop through. So I'm going to say 1 ... and then I have to give an end number here. So I'm going to say 10. So you give a starting number, ... and then an end number. So I'm saying 1 through 10. Then do an opening curly bracket. If you hit enter, Xcode will automatically give you the next one. So let's say I want to print something 10 times. Well, whatever code we have inside these curly brackets, this is what gets looped. So I'm going to put right inside of here, I'm going to say print, and I'm going to put in here hello world, the most classic programming example ever. And you can see this is kind of cool. So Xcode showing here on the right side in the playground, this was run 10 times. And look, down here at the bottom of the console, you can see hello world was printed out 10 times, right? So the classic example that I like to think about this is, remember Bart Simpson, anytime he gets in trouble, he has to write on the chalkboard, like, I will not disrespect people again, or whatever it is, right? If Bart had a computer, he could have it all done for him. In fact, there's a Simpson episode where he actually uses the computer to copy paste all the stuff, and he's done with his work in like 10 seconds. But isn't that cool that the computer just ran through all 10 of these super quickly? But you can do much more than 10. Watch this. Let's say we want to run through 100 times. That was almost instantaneous. And look, scroll through this. It did hello world 100 times. Why not 1,000? Check this out. Look. I mean, it printed hello world 1,000 times. It takes a second to scroll through this. Now, something cool I want to show you about Swift, if you've never seen this, with numbers, you can put an underscore in them to kind of just show a space, like, oh, this is 1,000, where, you'd normally put a comma. That doesn't affect the number any, but it helps us read. So let's say we want to go through 10,000 times, okay? So now you can see it kind of took a little bit to count up there, but what was that, 3 seconds? And down here, it printed hello world 10,000 times. I'm going to keep going. How about 100,000 times? Okay, so we change this. Look, boom, off to the races. Like, to me, this is why computers are so cool, is because we wrote 3 lines of code, and all of a sudden, this computer now is printing out hello world 100,000 times. You in your lifetime could probably never do that. 100,000 maybe, but I mean, as we get on to like the millions and billions and stuff like that, this is really cool that computers can do these types of things. Look, just by talking about how impressed I was, this thing was already finished. So I just think it's really awesome how this stuff can just go over and over and over again and not slip up at all. So that's where I'm going to leave it here for this one. Hopefully your mind has been blown with for loops, and take a second to kind of play with this. See how big of a number that you can build, kind of play with. I do have an exercise for you, so maybe play with the for loops in combination with that. But let's do that exercise and then come back here, dive into for loops again. Well, I hope you enjoyed walking through that exercise. Aren't for loops fun? Like, the amount of stuff we can do is just insane. It blows my mind. You'll notice I've changed my for loop here to only loop through 100 times. I couldn't exactly handle, my computer kept freezing when I was doing that big stuff, so I kind of brought it down. So you should probably do that too, just to make sure we're kind of on the same page here. But I want to talk about this underscore. What is the purpose of this underscore? Well, in our situation now, if you put an underscore in a for loop, basically that says, you know, just loop through the stuff inside of this range, and I don't really care about which iteration of the loop that I'm on. But instead of having a underscore here, you can actually put something in here. Like, I'm going to just type some name. I'm going to call it the number. Okay. So essentially what this does is it says, okay, every time I loop through the for loop, the first number that we're looping through in this range, like 1, we're going to have the number be equal to 1. So to kind of prove it to you here, let's just, instead of printing out hello world, let's do hello world, and then we're going to put inside of here the number. Okay. So look what happens when we do this. We're going to start at the top. It goes 1, 2, 3, 4, all the way down up to 100. Isn't that cool? We can also, you'll see if we mess with the range here, like if I say now go 1 through 10, just goes 1 through 10 like this. So each time it loops through the array, it says, okay, first time through, there's going to be a constant here called the number, and the number is going to be equal to 1. So that's why it printed out hello world 1. Then the next time it comes through the loop, the number is going to be equal to 2, and it just kind of moves through there. So this will kind of help illustrate with these ranges. It doesn't always have to start at 1. For example, I could go 5 to 10, and by doing this, it just goes 5, 6, 7, 8, 9, 10. Boom, just like that. We could go from 5 to 6. This is only going to run through 2 different times. Oh, looks like Xcode wasn't happy with me with that. Let's try again. There we go. So it just says 5 and 6. Okay. So we can use this to kind of manipulate what it is that we're working on in there. So I know that was a really small thing, but again, I have another exercise for you where I want you to work with both the range and this little number here, this variable that you can change each time that you're iterating through the loop. And then after your exercise, we're going to bring an arrays in here, and it's going to be a freaking party. Can't wait to show you that. So go tackle this exercise, and we'll keep moving. This lecture is all about taking what we've learned from arrays and applying it to for loops. It's going to be really awesome. So first, we need an array that we can even work with. So I'm going to go ahead and make a array here. I'm just going to call it video games. I'm going to save some of my favorite video games. Let's just go off the cuff. I'm going to say Super Mario, Tetris, and let's go Super Smash Brothers. Is that how you spell it? SSB? I don't know. Okay, but here we have video games, right? It's an array, and it's just an array of strings. That's pretty simple. Look how we can use for loops with this array here. So I'm going to come down, and I'm going to say for, and let's use just an underscore for now. I'm going to say for underscore in space, and instead of doing a number range, I'm going to put in here video games, which is the name of the array. Okay, and then I'm going to do my curly brackets. You can see it's very similar to what we did above here, right? Like instead of giving the range of numbers, we just give an array, and we could give a name here, but right now we just did the underscore. Okay, so now you can see the similarities. I'm going to delete this other one. We just want lots of clarity here as we're working. But notice this. If I'm going to just say print right now, and I just want to say something like hello. Okay, look how many times this for loop runs. It runs 3 times. that happens to be as many things that are in this array, and that's not a coincidence. Watch. Let's say I add another game, Nintendo Land. Okay, look what happens when we do this. It now runs through 4 times, okay? So when you use a for loop in an array, it basically says, okay, I'm gonna go through each item in the array. And if you haven't figured it out by now, if we give a name to this underscore, for example, if I call this game, we can actually know which item in the array it's currently working with. So if I print out game like this, look what happens. Boom, it prints out Super Mario, Tetris, Super Smash Brothers, Nintendo Land. Like it loops through each thing in the array and we can actually print that out. And that works whether this is strings, if it's ints, like whatever you want. But you can use for loops to loop through arrays. Isn't that excellent? So the reason that you might want to use this is, let's say you have an array of something and you want to see at what position Tetris is at, okay? Or let's do Super Smash Brothers in this case. It will kind of build anticipation a little bit more. So we want to find out what the index is for Super Smash Brothers, right? Like we know from just counting it's 0, 1, 2, but if this was a really big array and we didn't know, like we would want to have code to be able to test that for us. So we could say, for example, here, like if game, which is going to be the string of whatever it's looping through here in this array, is equal to SSB, then we know that is the Super Smash game. So I'm going to print out we got it, right? So let's see what happens when we write this code. Well, we can see that we got it, but we don't know what time, what index that we've looped through yet. So you might be wondering, well, how do I do this, right? When I had the numbers, it would take whatever the number was in that range and it was putting it through. Well, we can use our own kind of variables here and figure out this answer. So I'm going to say here, var index is going to be equal to 0 initially. And what we're going to do is at the end of each loop, I'm going to put down here index plus equals 1. So now as we go through, we can kind of count what number in the index of the array that we're working with, right? So as we go through here, the first time it loops through, it says, okay, index is going to be equal to 0. We get the first game, Super Mario. If Super Mario is equal to SSB, oh, it's not. Okay, skip down here. Index plus equals 1, so now index is 1. Then it comes through again. It says, all right, if the game, which the next one is Tetris, is equal to this, no, it's not. So it skips over. Okay, index is now 2. Comes through again. Okay, is Super Smash Brothers equal to Super Smash Brothers? Yes. And we could if we want to. And in fact, I'm going to do it here. I'm going to say we got it. Index is, and I'm going to pop the index in right here. I'm just going to say index. Okay, and look at this. We can see we got it. Index is 2. And look, 0, 1, 2. Let's see what happens if we change this to Nintendo Land, for example. Nintendo Land should give us index of 3. Boom, it does. Let's try it for Tetris. Let me select this again. Tetris. Yeah, check that out. So you can see how when we loop through an array, we can kind of use it to search that array and say, okay, what are we going to find in here? How can we do this? And we can actually, as we're looping through stuff, so for example, once we've found what we're looking for, we can actually break out of this loop early if we want to. So oddly enough, the term that we use to break out of a for loop is break. I know, pretty earth-shattering, right? But what we do is inside of here, we just put break. Okay, and what that does is it says, okay, as soon as I've hit this point, I don't want to move through anymore. So this might not look like it's doing much, but let's make it so at the bottom of the code here, we're printing out, for example, whatever the index is. Okay, so I'm going to print out, we don't need our little double quotes there. We're just going to print index. So if we don't have this break, what happens is, it runs through and it says, okay, 0, 1, 2, 3. That's where it's printing the index each time. And then also, because game is equal to Tetris, it prints this out. It says, hey, we got it, blah, 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 right? But if we put this break in here, you'll notice as soon as we figure out that it's Tetris and we say break, the whole for loop is over. It's just done. And the reason this is cool is these arrays can get to the thousands, tens of thousands, hundreds of thousands, millions, like really big numbers. And if you're searching through that array for something, once you found what you're looking for, you want to stop searching for that array, because you saw, as we were saying, okay, we want to, loop through 100,000 times. Even though computers are really, really fast, they hit a point where they just can't do much that quickly, right? Like it's like I'm going as fast as I can, but you know, if you've already found what you're looking for, there's no need to keep looping through the array. So that's why break is really cool there. So to kind of illustrate this again, I just want to emphasize, let's get rid of index as an example. I think this might make it a little bit cleaner. And what I'm going to do is make it so that we print, let's get rid of this guy too. And what we're going to do is we're just going to say print whatever the game is that we're currently on. So if we do this now, we'll just print out all the different items there. Let me, comment out this break so we can see what it originally looks like, right? Super Mario, Tetris, Super Smash Bros., Nintendo Land. But once we put the break in, as soon as we hit Tetris, it's like, I'm not doing anything more. I don't stop. Now, the other thing that you can do to kind of control the flow of this for loop is you can use something called a continue, okay? So I'm going to type continue here. And basically what a continue does is it says, don't run anything below here, but just keep going on to the next version. So right now, this doesn't look anything different than if we didn't have a continue, right? Like if I comment this out, still shows all 4 games. If I put it here, still shows all 4 games. But you'll notice if I move this print down below here, so I'm going to go ahead and put that down there. Look what happens. We never print out Tetris because what happens is first time it comes through Super Mario, okay? The game's not equal to Tetris. Super Mario's not equal to Tetris, so we print the game. Boom, there's Super Mario. Next time through Tetris, yes, Tetris is equal to Tetris, so we just say continue. And continue says, all right, don't run any other code inside the rest of this little for loop chunk, but then just move on to the next item in the for loop, which is Super Smash Brothers. And you can see it moves through and does its thing. So break and continue, those are the 2 things that you can use to kind of control your for loops, okay? So that's all I have for you. Hopefully you really loved learning how arrays and for loops work together. I think that's where real magic happens in kind of combining these 2 things. So I've got an exercise for you. Then after that, let's wrap it up with an outro. For loops, you hold a special place in my heart. I love just running things like 10,000, 100,000, million times right in a row. It just seems so cool to me, right? Something we can never do as humans. These awesome computers can do for us, okay? You also learned about how to work with arrays and for loops, right? That's going to be some pretty powerful stuff going forward in Swift. So hopefully you enjoyed learning about this. We have in the next lecture for you a close friend to the array, and you can also use for loops with that, but we'll talk about that in the next section. Let's go ahead and keep moving. This section is all about telling you what's new in Swift 3. So I assume you've written some Swift 1 or 2 code, maybe you have some projects there, and maybe you're deciding, hey, should I move to this new Swift 3? Or you're like, I'm all on board, I want to know what the highlights are. Well, this section is going to cover that for you. Now, there have been a lot of changes to Swift, and luckily Swift is open source, so we can see all these changes out in the open. And if you want to see all the nitty gritty, go to swift.org. You can see all the great information there. But this section is more kind of the highlights. I kind of looked through that and said, I think this is what will really impact people and they'll have to make decisions about as they're moving to Swift 3 or if they're trying to consider that decision. So those are my 2 goals here, is to 1, inform you about all the new stuff in Swift 3 and help you decide, hey, should I move to this new Swift 3 or not? I'm going to help you make that decision. Now, I will say there's a little bit in here about stuff that was already introduced in Swift 2.3, but there's a lot of people still on 2.2, so I included some of the stuff that was from 2.3 and included in 3. So without further ado, let's jump into it. So before I dive into the nitty-gritty of all the programming things, I want to talk about one of the big goals of Swift 3 that is not necessarily there right now, but it's something called ABI stabilization. And if you're like me, I had no idea what that term was when I first heard it, but basically ABI stabilization is a goal to make it so that when Swift 3 comes out, you'll be able to write code for Swift 3, and that same code should be able to run on 3.1 if there's eventually 3.2 or like a Swift 4. Like the kind of key parts of the programming language should stay constant so that as we upgrade to functions, like your code won't break as you're moving to new things. Now, for me personally, I am very excited about this goal and that people are working on it because I started teaching Swift as soon as it came out. I literally made a class 4 days after Swift was released, and it was just like, obviously Swift was still in beta and then it wasn't even a 1.0 form, but it was like, 2 weeks after I had filmed that, the way the arrays were created completely changed. So I had to go back and change all my videos. Like the way that you create arrays is no small like little fix. Like that is a pretty fundamental thing. And with each release of Swift, even from 1 to 1.1, and as we move to 2, like there's been some pretty big changes that will completely destroy your code that you got to go back and fix. Like it's a really big deal. So I personally am very excited about this. Now, the people working on Swift have admitted that they don't think that ABI stabilization is going to be completely ready in Swift 3, especially 3.0, but they're hoping to have it hopefully sometime in the 3 lifespan. So maybe that's 3.1, and in a worst case scenario, maybe it's Swift 4. But the good thing is that everybody's working really hard to decide on what should the language look like. There's some really cool things that I'll mention in this section, talking about decisions they made that said, no, you know what, this really doesn't make sense, we should do things this way. And they're trying to have all those arguments and discussions right now so that we can kind of decide on a nice solid version of the language and move forward from there. So just wanted to mention that that's something that's not necessarily in this version of Swift 3, but it will be at some point hopefully, and if not for sure by 4, at least hoping for that. But here we go, we'll move into some real programming in the next one. So this lecture is about the death of plus plus and minus minus. So I think this is something that was included in 2.3, but like I said earlier, a lot of people are moving from 2.2, and this is, it's not alive in Swift 3. So if you don't know what plus plus and minus minus are, basically if you have an int and you just want to add one thing to it or subtract one thing, we saw it a lot with kind of those C style for loops, you could do that. So for example, I'm going to make a variable here called age, and I'm going to set it equal to 8. So let's say I want to add 1 onto 8. Well, you used to be able to say age plus plus like this, and it would add 1 onto age, so then now age was 9. Now you'll see you'll get a warning here, so it's not necessarily broken, but it's saying, hey, this has been deprecated. It's not going to be a part of Swift 3. It's kind of funny because we are in Swift 3, but it might just be like a beta thing here. But really, what's the simple way to fix this? All you do is plus equals 1. So a little bit extra code, but this is so much clearer. I think the discussion around this was, as you'll learn later, C-style for loops are going away. So they thought we don't need it for that. And this is just so much more clear. If we have less and less of these kind of little special tricks for different situations, Swift will just be a much more clear language. And I think this is great for people learning Swift, right? They don't have to learn about plus plus and then plus equals. Like if we just have this plus equals thing, that's something that's pretty common. How much harder is it to do a plus equals than just doing the plus plus? Now, I know not everyone's on board with this. I would love to hear what you think if you want to leave like a comment to this video. But anyways, plus plus and minus minus will be dead. Again, if you want to fix that, you just have to do minus equals or plus equals 1, and that'll fix it. So as I mentioned in the video before, C-style for loops are dead. And if you're wondering what kind of for loop that is, they're ones that look like this, where you say for var I is equal to 0, and then while I is less than 10, we're going to do I plus plus or plus plus I, right? And it's going to loop through all these things. Now, interestingly enough, it'll still work, but you get this warning that says, hey, this thing is going to be replaced in a future version of Swift. So Xcode actually has this little replacement for you. If you choose this, just say for I in 0, then less than 10, go ahead and fix it. So it's pretty neat. And honestly, I think this is so much clearer. Again, I love that we are working on Swift to make it a very clear programming language. I would probably change this to something like, maybe change this to go to the number 9 here. And I'm going to add one more dot. I just think that's much clearer. But you can basically just use this range thing to do essentially what you wanted to do before. You still have this, I that you can use, which holds whatever value it is you're moving through in the range. And if you don't want to use that, just go ahead, do the underscore like this. Still works just as fine. So C-style for loops, you dead. So I was really excited for this next change. In Swift 3, when you have a function, right, that has some parameters, like this one, it says add 2 numbers, and I have A and B, it returns back an int and just adds those numbers for you together, right? Pretty simple function here. So in the old Swift, if I would type out, add 2 numbers, what it would do was it usually wouldn't list that first parameter. You'd just put in some number, like you'd put in like the number 5, and then I'd put in like the number 7 here, and it would go and add these 2 things together. But you'll notice now when you do that, you get an error and it's saying, hey, you've got to, include, okay, looks like Xcode beta crash. Let's try that one more time. But now you have to include the name of that parameter when you're calling the function. So we have to put inside of here a little a with a colon, and now everything will work. So I really like this change because I can't tell you how many times when people were learning Swift and I'd be telling about function, I'm like, hey, you can do these parameter things. And if there was ever more than one parameter, they'd say, well, how come the first one, it doesn't show the name of it, but then the next one does? Like, and I never really thought of it. It just seemed natural to me, especially since I came from an Objective-C background. I just thought, that's just the way it is. Like, you know, that's just how we do things. But no, that is really kind of strange. If we're going to have name for these parameters, we should actually use them. Now, of course, you can go and get rid of the names for these if you want to, but this is the style that's going to be required by Swift unless you specify it, and I think this is a really good move for Swift. So this one's a little bit more of a style thing, but I still think it's pretty important. With enums, we're going to, instead of making the cases capitalized, we're going to make them lowercase camel cased. So let me explain that real quick. But so when you're creating an enum, still capitalize whatever the name of that enum is. But for the cases, like traditionally you would say direction.north, and you keep these capitalized. But now the new suggestion is to do like lowercase n, lowercase s, lowercase east, and lowercase west, right? So change all of those. Now when we hit this, it's like, okay, we have lowercase versions of these. Now the uppercase, it's not like it's going to break your code, but this is more of like a style guide that people have put forward to say, hey, let's all as a Swift community use lowercase here for our enum cases. It's not going to break anything. And you can see this, they've made some changes, right, to their standard library. So if I do optional dot and I look at start typing like none, you can see this is lowercase. This used to be uppercased. But yeah, it's just something to be aware of there. Now I said these are lower camel cased. So for example, if we have some other case in here like north, northwest, you know, we could say case north, northwest, right? Like we still, as long as there's new words inside of a case, like we should capitalize the beginning of those, but just not the very first letter inside of there. So again, just a style thing, doesn't break your code, but important to know for naming things in the future. I believe this also applies to static properties inside of some objects, so just be aware of that. So this lecture is a little bit of a combo. I'm going to be covering a couple of different things. So one is, there's just a bunch of name changes everywhere where a bunch of names have gotten shorter. So for example, when you're working with arrays, like I'm going to make an array here, just an array of dog names, right? And I want to insert something. This used to be insert at, now it's just at, and you'll see just tons of places that things have been shortened. If you have issues with any of those, Xcode is going to make it really easy to transition to the new one. I'm going to show you that in the next lecture. But also same thing with like UI color. Like UI color used to be dot red color, now it's just dot red. And doesn't that make so much more sense? UI color, we already know we're working with colors, dot red. Like, yeah, why would we repeat the word color? Like, I just think these are awesome changes. Now, one thing to note here, remember how we talked about with parameters that it always has the name here, and you're like, whoa, why does this insert function not use that? Well, it's still possible to not have that named, and in this situation, because you know, you're going to be putting different things in here depending on if they're ints, strings, whatever you have an array of. But I think this is a situation where it makes sense because we get the name from here. You could argue that no, they should stick with this and, you know, put like the term item here or something, but it's still a possibility in Swift. So that's kind of a great example of that. The next thing is something called color literals. So if you want to change the color of something inside of your app, you can just use, if you just start typing color, you can see the Swift color literal. You hit enter on this, you can just pick a color from this like switch thing, or you can hit other. Now you got this like awesome thing where you can just pick any color in the whole freaking world. So, you know, you can do that. And I think if you double click on this, yeah, you can get back to choose some other color. But this is compatible with UI color, I think, in most places. Like I was experimenting with this with just the UI view control, and I set the view's background color to like one of these, and it works. So it's kind of this cool idea about how you can just see the color right there. inside of Xcode and, not have to say dot, especially if you're doing custom colors with all these numbers. Like, it makes sense maybe just do this. I also on some level think, no, the number thing's actually kind of a good idea. So I've also heard talk of this working with images. I haven't worked on that by myself, but I thought I'd at least share that. So shorten names everywhere, and there's these really cool color literals. So the last thing that I want to talk about in this lecture is about how you can take your existing Swift projects and convert them to the new version of Swift. I think Apple has done a great job of this with Xcode, and it's really quite impressive. I'm going to show you an app that I made in Swift 2 that I'm going to move over to Swift 3, and it really fixes all the issues for us. And it's going to be nice to kind of at least look through those errors at first to see what issues there are, and then we can talk more about it and show how awesome this tool is. Now, for more complex things, maybe it's not going to work as well. Again, this is a really simple app, but I think it's pretty promising. So let me go ahead and open up this app that I created. Here we go. And it pops up. So the first time you open up a project with the new Xcode 8 that's using Swift 3, it's going to ask you, hey, do you want us to convert this for you? You can always say later and then go to the edit menu and do this conversion yourself. So for us, I want to hit later just to see what kind of errors we're getting. So I'm going to hit run right now just to see what we get, and we can see, whoa, we also have all sorts of warnings and errors pop up. So go ahead and click on those, and you can see some of the things that we have here. So if we look at this, there's just kind of some name changes. So this capital S is going to a lowercase. Again, that's that kind of enum thing, right, where we're going to lowercases, not capital. There's a ton of thing with the name of functions where that whole thing about having, a parameter at the beginning, is just changing how things look. So just instance after instance here, all sorts of issues. The good thing is Apple knew about this and has made Xcode handle them really well. Again, we get some warnings here where they have suggestions too, just tons and tons of stuff. So if you want to fix these and have Xcode try and do it for yourself, I really recommend using some sort of version control. So like if you have Git, check in the current version that's in Swift 2, then go to editor, do this. Oops, didn't mean to use editor. We want to go to actually the edit menu, then go down to convert, and it has some options here. You can convert to Objective-C Arc, modern Objective-C syntax, but we want current Swift syntax. So click on this. We'll hit next. It gives you this option to say, do you want to go use Swift 2.3 or Swift 3? That's really cool. In Xcode 8, you can use 2.3 or 3. I think it's awesome that Apple is giving a choice and not just saying, use Swift 3. I think that's a really awesome position by them. So we're going to say use Swift 3, hit next, and we'll say, yes, we want to do this for my Friendbook app. So it's going to work on converting all those files, and then it will show me all the changes that it's going to make. And you can see each of the files where it's going to make those changes. This one's probably, this is where a lot of things are happening. So if you trust Xcode enough, like I said, make sure you've checked into some sort of version control so you can get back to the old one if this just screws things up. But when I do this and I hit save, it's saying you really want to make sure you're doing this. I hit continue. It'll go make all those changes. And now if I hit run, all of my errors went away. Still have some sort of setting thing that I need to work on. But I mean, all the Swift changes were fixed with their tool. So it's obviously probably not exactly perfect. This was a very simple app. All it does is list the 4 friends from Seinfeld and show fake information about them. But you kind of get the idea that, this could probably help you move to Swift 3. And like we showed throughout this section, there's some really cool things with Swift 3. So look, our app's actually popping up here. We could check it out if we wanted to. I'm going to go ahead and roll a little bit of an outro here just to kind of sum things up. I will click on this so you can see the different people from Seinfeld. Oh, Kramer, you're beautiful. But yes, let's go to the outro. So I hope you enjoyed learning about Swift 3. I also hope you've decided to move from Swift 2 to 3. I think it's a great move. There's that awesome Xcode tool to move you from there. But I think an even bigger point here is remember I started talking about ABI stabilization. Again, there were some pretty big changes, especially with like the plus stuff and the C-style for loops, and especially the parameter thing. The parameter thing, that's actually huge. I think that's where most people are going to see errors inside of their code. So yes, these are a big deal in that we have to rewrite a lot of things. I think Xcode is going to handle a lot of that, but These are not as big as some of the other things that we were changing when we saw Swift in beta, then go to 1.0, and then from 1 to 2. Like, we, I think, are moving to more and more stable version of Swift, which is excellent. I think the more stable we get, the stronger and stronger the language will be, and the more places we'll see it. I'm really excited that we now have like some server-side Swift stuff. I still think it's way too messy and complicated to get up and running for kind of the average or even intermediate programmer, but you know, we're moving there. There's been rumors that Swift's going to be on Android. I highly doubt that's going to happen, but if it did, that'd be like amazing. Like, the places that Swift's going to show up is just really exciting to think about. So there you go. I hope you enjoyed talking about all the new stuff with Swift 3. If you have any questions, comments, I'd love to hear about them. Please post something in reaction to this lecture, and I'll be there to talk about it. See ya. In this lecture, I'm going to teach you how to get Swift up and running on your Linux machine. So here I have a little version of Ubuntu running on a virtual machine on my Mac, so I can kind of show you this process. And it's really easy to get Swift up and running on Linux. I think the people that work on Swift have done an amazing job with this. It's super great. So the first thing that we need to do is go ahead and download Swift. So open up a browser, any one that you want. I'm going to be using Firefox here. And we just need to go to the Swift webpage to go download this, which is swift.org. So here we'll wait for this guy for just a second. There we go, popped up. And we just need to go swift.org. Awesome. And make sure the screen's big enough, your browser is, so you can see this little menu on the left. Okay, got that big. We're going to go to download, and then we will scroll down until we find Swift 3. Now, as the time of recording this, the official release is 2.2.1, but Swift 3 is in beta, and so hopefully eventually Swift 3 is going to be the first one up at the top. But right now it's in preview beta mode, so come down here to where it says Swift 3. So I'm running Ubuntu 16, so I'm going to download 15, I think, which is close enough. That kind of matches mine. Depending on what you have, go ahead and get that one. Then I'm just going to select Save File so that it will come onto the computer there. So look at this. Swift is 106 megabytes. This might seem fairly large, but compare this to the 3.8 gigabytes that you need to download Xcode. This is definitely where the Linux people, I think, have an easier time than people who have to go get Xcode, because that is a huge download. So eventually that all finishes. We can close out of our browser now. And I'm going to open up the file menu here. I'm going to go to downloads where we found this guy. Double click on that, and it comes in a compressed form, so we need to double click it to extract it, get every all the Swift stuff out of there. You can see it's working on that. So now we need to click this extract button to actually save it onto the computer. I'm going to put it in my home directory here, and I'll just hit that extract button. Okay. So there it goes. It's going to put it in my home directory. Now I'm assuming, since you're using Linux, you've probably used the terminal before. You know, if not, this next part might be a little bit confusing, but just follow exactly what I do and you should be able to get there. We need to open up the terminal. So I'm just going to come here to search and search for terminal. Okay. So there it is. I'm going to click on that. And what we need to do is enter in some information so that we can run Swift from anywhere inside of this terminal. And if you don't know, the terminal is basically a place that you can kind of run commands on your computer. You can move between directories and stuff like that. But let me show you the line that you need to enter into your computer. So I forgot, the instructions about how to install is actually on this download page of Swift. So if you scroll down here, it tells you how to install it on OS X first. Let me get to this point. Dun, 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 dun. Okay, there we go. Apple platforms, yeah. But we want to get to Linux. There it is. So we need to come down. I think it's step 6 here. A little more. There it is. So we need to basically do this export path. We need to add it to the path so that, as it says here, you can now execute the Swift command to run the REPL or build Swift projects. And now you can do that anywhere inside of the terminal, not just where you have Swift installed now. So what we need to do is get back to this terminal. And right now, this is in the home directory. So if we hit LS, it will show us what's in that directory. You can see where we installed Swift and all that good stuff. So let's go ahead and write our line here. So we need to do export path. Let me move this up so I can see both. So I'm going to do export space capital path equals, and now I'm going to go to, I have to list out where my Swift stuff is. So I'm going to do this little, I know the name for it's like tilde or something like that, but basically the squiggly. Go ahead, do the squiggly. That means the home directory slash, and then now we're just going to type whatever this Swift file is. For you, it might be different, right? Because mine's preview 1, yours might be preview 2, or it might not be a preview at all because Swift maybe is out of, you know, preview or beta mode here. But for me, I'm just going to start typing Swift, and as I do this, if I hit tab, I get the autocomplete, which is great. Then we need to do start typing user. So if you do U, it should autocomplete. Then we need to do just /bin like that. Then we do a colon, quotation mark, double quotes that is, $, curly bracket, not a regular parentheses or a square bracket. We want a curly bracket, all capital path, curly bracket, and one more double quote, hit enter. Now, if you've done all of this correctly, you should be able to just type Swift, and this thing called the Swift REPL should open. And so this is a place for you to write Swift code just directly here into the terminal. So for example, if I type print, double quote, hello world, all right, then do the ending parenthesis there, you can see it will spit out hello world. And I can, if you haven't dived into the rest of the class, this might not make sense, but if you have, you can see I can like create variables and stuff here. I'm going to make a constant. I'm going to say let a equal 5 and let b equal 10. And I can do like b times a, and it will do the math for me. You can see it spits out 50. So it's kind of cool like that. To exit out of this, you just do :q, and that will exit out there. The other thing that you can do is actually make a Swift file and then just run that Swift file. And that's what I recommend for this course. As I'm teaching you things and you're going to work on stuff, type it in some sort of text editor. You might have a code editor that you like on Linux, and then just run that Swift file. So I believe here on this machine, if I open gedit, I can make a new file. So on here, I'm just going to print, this is from my text editor. Okay, so I'm just going to print this out. So this is just a line of Swift to make sure things are working. Then I'm going to hit the save button, Control S, and I'm going to put this in my home directory, and I'm going to call it nick.swift. Might as well call it my own name. I don't really care, but just make sure you have .swift at the end. Okay, so as long as you got that, hit enter. Then we will come back to the terminal here, and let's do an ls to make sure that that Swift file is there, just like we were hoping for. Oh, I'm still in this text edit thing, so I'm going to do ls. There we have it, nick.swift. So now I can simply type Swift space and then the name of my file, which happens to be nick.swift. Yours may be named differently. And I do that autocomplete thing. If I hit enter, boom, you can see this is from my text editor. So the code that you write inside of this, as long as you run that file, you know, save it, update it, whatever, and then you go run this line, you say Swift and then the name of the file, it will run that Swift code for you. So that's everything you need to get Swift up and running on your Linux machine. Now, it's going to be a little bit different from running in the playground. So if you're going to be watching the videos, you kind of got to work on a flow. But if you have any issues, I'd love to help you. I'd love to explore this area more. I'm pretty new to Linux stuff. I think it's interesting. I love the idea of open source. So you probably have a lot to teach me. I may have some things to help you, but I'd love to talk with you more if you're kind of in this world. So hopefully it was helpful, and let's go learn Swift. This lecture is designed to help you if you have a computer running Windows, yet you still want to work with Swift. Now, I have a little bit of bad news, and that's that no one has created a really great solution to have Swift running on Windows, but Swift is open source. There are people that are working on it, and I think there will be progress. I guess by the end of 2016 that we will see Swift fully on Windows with a pretty easy setup. As for now, the way that you can get Swift running on your Windows computer, which you can, is you can do it through the browser. So IBM has created this tool that allows you to run Swift in the cloud. You can completely do my class while using this IBM tool and finish things. So open up a browser on your Windows computer. It can be Chrome, Firefox, Internet Explorer, whatever you want, and just search IBM Sandbox Swift. Okay, so search that, IBM Sandbox Swift. We want to click on this one that's like swiftlang.ng.bluemix.net. Okay, so go ahead and click on this, and essentially what you have here on the left is your fake Xcode where you can be working on stuff. This is your playground. So for example, here's a line of code that says print hello world, and if you hit this run button, you can see that the text will show up over here. Now the thing is, when you have a the playground open on Xcode on a Mac, you get this really cool feature of just as you type stuff, if I change this to hello world, I am cool, you should see the results of that automatically show up over here, and you wouldn't have to type this thing print here to go see that information. Whereas with this IBM tool, you do have to do that. So you have to hit this run button to see anytime you make an update, make sure that the code's okay, and all that. So I will say a side bonus, Xcode's not always perfect, and sometimes it crashes, so it's kind of nice that you can have this online thing when you decide to hit the run button, because sometimes if you're not careful with that, you can have some real issues. But yes, this is how you can do this. I hope to have an update to this fairly soon whenever there's a great solution to get Swift on a Windows computer. But for now, go ahead and use this, and let me know if you have any questions.